want to set the foundation. That's why we started with Agnes. Then I'm going to talk about, just introducing the tools and the methods for breeding scheme design. So you remember this is about how to design a breeding scheme using quantitative genetics principles, the summary of all the simulations from the questions that you did, addressing crossing, evaluation, or selection decisions. So I'm just going to present the tools and methods, but probably this will help anyways. I hope that you were able to connect with your computer, to the Wi-Fi, because we're going to need it like in about an hour, something like that. So yeah, if you have to connect your computers because your battery is low or something, just go for it. So in the other trainings, I was starting with the same story that I always start about Richard Feynman and listening and asking questions, but because here doesn't seem to be a problem, it seems like everyone is asking questions well, I'm going to skip the story because the final lesson was that feel free to ask. But it seems that here people is even asking during the presentations, so no need to worry about motivating you to ask questions, which is good. So you already know this picture already for a long time. It was actually you, the breeders, who proposed this more or less like a decade ago. It's even actually in some of the Rex books about using or seeing breeding as a process, where they used to propose, okay, we need to start approaching breeding as any other enterprise, where there is clear processes, clear phases. And like I said, you already know this picture. We have been kind of promoting the idea of seeing breeding as a process of design, engineering, and delivery, and don't hang up with the names too much. You can name it as you want. The whole point is that we want to approach breeding as a process. Even some companies are starting to call product design breeders, population improvement breeders, product development. We kind of more or less use the same language or vocabulary, but there are some subtle differences. But in general, as Agnes was pointing out, it's different the what to the how. Agnes was talking about presenting these opportunities or these investment cases, identifying the targets, the market segments. But in general, once that has been done, basically we want to make sure that we can design the breeding scheme to attend that market segment. And I know that there is a lot of confusion, so I actually took the time to put also the stage gates that Peter has been talking with all of you, the stage 0, product design, trade discovery, trade deployment. Actually, Agnes was referring to these stage gates. And I know that sometimes it gets a bit confusing. The whole point that I want to, kind of say here is that we're talking about the same thing, the process of breeding. It's just that when you talk to Peter, when he started to put the stages, he was saying, okay, product design, trade discovery, deployment, crossing and screening, early testing, late testing, pre-commercial, product commercialization. But it was always, it's up to you. You define how do you want to see the process, what stages do you want to use, but just keep in mind that it's the same thing. And of course, we have been talking that you actually fit from the last part of the product design, so getting involved with all the team, the interdisciplinary team that come up with the targets, but mostly commercial people, market intelligence, socioeconomists, etc. But you're doing the real work, right, which is running the breeding program. But of course, there can be different types of breeders, right? I think this has been emphasized by many of you. It might be that sometimes we talk about the pre-breeder. Some other people might call it, the trait introgression breeder, or the early breeder, et cetera, et cetera. Then we have also the population improvement breeder, the product development breeder, and maybe also another breeder that works also in trait introgression towards the end of the pipeline, where you just need to introgress maybe some transgenes or something like that. And the problem is that most of you, wear 4 different hats. In some institutions, it might not be that way, right? So there will be a specific program handling this area, and a specific program actually doing, for example, in the current world, there will be the line breeders in this area, and then you will have here the product development breeders also as a separate, taking the products from these individuals, and then another program bringing the introgressions at the end of the pipeline. But for now, the training here is about breathing scheme design for the entire week on how to help designing some of the decisions for crossing evaluation and selection. Like I said, not based on what we said. We can only just tell you what we found out of your questions, and you decide at the end what to do. So the entire week, we're going to go this direction. You can see that we started with product profile, market segments. Then we're going to talk about the actual process of breathing scheme design. And then we're going to go through the different crossing evaluation and selection decisions. So we're going to go and talk about field trials, the METs, the program size, genetic variance. You might remember some of these questions that you were asking, how to manage the variance, how to use what is the best selection method, best surrogates of selection, blues, blobs, G blobs, et cetera, et cetera. Oh, you remember, Elisa? I thought you were going to. And then, the fast recycling and the genomic selection or the genome-assisted methods, right? So we're going to go this direction. That's why I'm just asking you, to bear with us, slowly building the story so we can understand where everything fits. So you can see the product manager, Bish, and Ronnie, the banana team lead, what he found after, taking this training. Nah, just kidding. We were just in Tanzania, and we were traveling, and they found those massive bananas. But I thought it would be nice to pretend that that's the result of taking this training. So, all right. So I think you have also seen, some of you, this slide. I know that we don't like to be compared with any other industry, but in general, I just want to emphasize that in almost every sector that you look at, there is always this important aspect of designing properly the products, then making some engineering to make those products, and then delivering those products. And the reason why it's important to split, the different areas is because you allow people to specialize. I mean, we don't doubt that you went to the best universities in the world. We know that you can do basically every aspect of breathing. We don't have any doubt about it. But the problem is that if you want to cover all, it's very unlikely that you're going to be able to specialize to the level of detail, to bring this to the state of the art, basically to be able to get to the best of the best of the best product. You might be good, running a program and maybe staying here if you are alone. But if you let one of your members, one of your breathing experts to specialize, let's say in biometrics, this person might be able to, come up with a good analytical pipeline with the state-of-the-art, data management, et cetera, and that will allow the other areas to basically move into really becoming the state-of-the-art for other areas. So the same with the trait. I mean, if you also want to cover the trait integration area, okay, you might be able to cover it. But I mean, can you really take it to the level where some of you, for example, know Damian, right, from the Erie Rice team? I mean, that is an example of letting someone to just really become the expert of the expert of the expert in that area, right? The same with some of our biometricians here, right? If you let them just exploit and go in that direction, letting this process to really put some differentiators, some lines there, it really helps to get the products, evolved. And I think that's what we expect, and I think you also are with us in those ideas. So Agnes was actually sharing with us what is the team members that we need, the tools and the process to come up with those blueprints that we call the product profiles, and also with the market segments. And there was a long list that I didn't want to repeat because there was like 12 different roles. But the market specialist, social scientist, breeding specialist, and so on, so on, so on. The tools, you saw there is templates, there is databases, there is blueprint tools, marketing intelligence tools that these people use. And then, the process. Agnes was explaining how to, get this information, get the percentages, narrow down the market segments. Then you have these market segments to focus, then create a product profile. I guess we could also have a workshop later, Agnes, where you just teach us how to basically build the product profiles from A to Z. But for now, this week is mostly about the breathing scheme. So once we have those product profiles, how do we move to the next step, which is the part that you care? Mostly this is technical people, right? Heads of breathing, breeders, biometricians, quantitative geneticists working together to get the technical aspects. So the engineers, you know, well, I don't want to say the brains because there's also brains there, but you get my point. the technological people, let's call it. So we're going to talk about a little bit about the tools. So, you know, what are the tools that we think are useful for you to become the designer of a breeding scheme, and the actual process. I mean, how will you do it from A to Z? This is just a summary. We'll go one by one. So I will just go to the next one. So we're going to start with the actual tools. And you know, this is what we've been learning with you, what we have been bringing from other areas and from other institutions, etc. So we're always happy to hear about your thoughts and ideas. But you know, between the tools, I know that you're getting tired probably of me talking about project management and Six Sigma and all that stuff. I know that at this point it's becoming boring. But one of the most important tools that I just want to say first is the project management and continuous improvement. The reason why, you know, we've been talking about using the project management tools is because if we want to go towards a process, the process of breeding is really, really complex, really complex, too many decisions to take. And it's difficult to actually manage a program if you don't have a structure to really see that, okay, these are the different areas that I'm handling, and these are the different projects, and you know, allocating properly the resources really requires some project management skills. So you know, when I say project management, I basically refer to these project charters, you know, the fishbone stuff. You have heard Gustavo probably also a lot. The SOPs. You know, even the SOPs, they look so simple, but just making sure that if your technician leaves next week, that you don't have to, you know, basically train this person again for several months. That basically you say, you know, first you read this SOP, and then when you completely understand it, then we talk about, you know, we go and see it in the field. Just having those type of documents that shouldn't be big. I've seen some SOPs that look almost like entire manuals or books. You know, that one page, you don't have to say, according to, you know, Covarrubias and colleagues, that's not an SOP, right? That's a paper. The SOP just says like a protocol, add 5 milliliters, and that's it. You don't have to question why it was 5. It's just 5, just do it. So those are always useful. And the continuous improvement, well, you cannot build continuous improvement if you don't have a process, because what you improve is a process. So first you have the process, you actually document the process, and then you improve it. I guess that was the part that at the beginning we had some issues, right? Because we were starting to work, and we were asking about, okay, let's improve the breeding scheme, and then we said, okay, but where is the breeding scheme? Oh, well, no, I don't have the breeding. I mean, I know it. It's here, and it's in my book. But sometimes what we needed was to formalize it. So that's why you remember that we made this effort to map the breeding schemes in this Excel, later in the breeding pipeline manager, just kind of to build the foundation that if there is a market segment that is being attended by this pipeline, we wanted to see what is that process behind. What we found in several cases was that there was already a clear process. It was just a matter of putting the numbers, which was great. There were some other cases where instead of, you know, you were putting the numbers, you said, oh, but actually last year, I mean, this year was 100 crosses, but last year was 50. And the last year was 200. And the previous year was actually 10. So that actually, you know, was just, well, it's not that it was, well, it was bad, but the whole point was that we were trying to learn how to become this like a standardized process, right? We cannot tell, you know, a candy factory to put this year 10 grams of sugar, but next year to the exact same number of candies, 100 grams and 300, and expect that the exact same product is going to come out, right? So that was kind of the lesson, like, hey, can we just try to put some formalized breeding scheme? And I think that went very well. You helped us a lot. You did a great job in just putting those breeding schemes together. And you know, one of the reasons why it's good to have that process in place is because, like I said, we can build on that, the continuous improvement. You know, there's a region here in Mexico called Puebla where they grow mushrooms, and they are really good at it. They actually, you know, make good money, but this is how their facilities look like. And you know, they made it. I mean, they keep selling. They feel like they are doing well. That's not a problem. But then just for curiosity, because I like mushrooms, I started Googling, how does a state-of-the-art mushroom farm looks like. And it seems that in Australia, they have this type of farms where, they have everything with robots and sensors and lights and just automatically harvesting the mushrooms and detecting when they are ready. And I was like, okay, well, that's nice. I just hope that, these two programs don't basically face each other at some point, because I think it's very obvious when these two face that it might be that one will win the market over the other. But I'm not saying that we have to go from here to here, but if there was a process in place, you probably can start thinking how to improve this process. Maybe not get to the robots if that's not necessary. Also, maybe the market is too big. We don't have to worry about the people in Mexico by the people in Australia, but who knows? But yes, that's why the continuous improvement is useful. So before I move to the next one, so I'm not trying to tell you to become a black belt or green belt or as many belts are there in project management. You know that there is many belts. No, just see what tools might be useful for you. Is there something that you can take from the project management and continuous improvement area to make your breeding program better? If there is, take it. I mean, we have been putting some ideas there, but it's not necessary that that you take a 1-year course to become a certified project manager. We don't think that's the direction. The other type of tools, which I think that these are well underestimated, is the blueprint tools. So when it comes to designing any other product, you probably have seen that the other experts, they have a specialized software. For example, an architect may have AutoCAD, or maybe also someone that is designing something like a car, etc. But somehow, in the case of designing a complex breeding program, we don't try to create these sketching and blueprint tools. We just rely that, okay, let's just take PowerPoint and that should make the job. And it's not that it's bad. I mean, as long as it works for you, it's good. But that was actually one of the motivators to build that breeding pipeline manager for you. We're not telling you that you have to use it. At the end of the day, it's your decision. We can just give you recommendations. But the purpose was that we thought that you will find useful to document and you have formalized your breeding scheme in a tool. So like I said, so if the next person that wants to talk to you wants to know how your program works, you don't have to spend hours or days. Probably you spend a lot of time with BPAT when you had to explain your breeding scheme. But if there was a place where they can just go and read, oh, this is how a breeding scheme is read, blah, 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 and they get it, then the conversations would go faster. Even with us, right? When we were getting this information for the simulations, it's just because we needed some detail, and we can get lost in the details very quickly. So yeah, these are the type of tools that I think, you saw the publication. Actually, we tried to put it together with some of the IITA people on the breeding schemes and how to formalize them. We're actually going to make a quick exercise with the breeding pipeline manager, just to give it a try and to get some feedback from you. But in general, you can look for other blueprint tools if you want to, or you can build your own, or you can take this code and just build it and make it better. But we really recommend that you try to sketch your breeding scheme, because the whole point is that now we have a clear target. Now you have to design a breeding scheme, and to design it, just the simple word or the single word of design, it means you have to sketch something. So we'll go over that. So I think in case of some people, it's not related with the vocabulary that we use. We also have some national partners here. When we talk about the breeding scheme, we have been talking about all those crossing evaluation and selection decisions that that show up in the breeding process. So some evaluation decisions might be what is the plant portion that I'm going to harvest? I mean, what is experimental design, the number of locations, the replications per location, the size of the plots, am I using sparse testing or not, how many checks, why am I using those number of checks, when am I recycling, what type of method I'm using to recycle, all those crossing evaluation and selection decisions that show up at the different stages in the process, so those stage gates, in the early evaluation or in the crossing, etc. So imagine those for a minute, all those decisions like little columns and all the different stage gates in different rows. Basically, all those decisions that show up, that is what we call the breeding scheme. Basically, your strategy to breed for a given target, in this case, a product profile. It will go kind of more details, of course. The whole point of this week is to actually address the results from the simulations, from your questions on, okay, then Eduardo, what happened if I do two-way cross versus three-way cross? What will happen in this breeding program? All those questions will be shared with you because that's what you hired us for. So the other type of tools are the modeling tools, right? We've been talking that it's not just about having a clear process and managing it with good project management tools and being able to sketch it. You also want to sketch possible alternatives, right? Possible routes. And these possible routes, basically this is the current way that we address the breeding scheme design. So there is stochastic genetic modelers, deterministic genetic modelers. So the stochastic are those ones where we can simulate kind of the randomness of nature, right? That we can simulate that you make a cross and you generate 100 progeny, but if you do it again, then you get a different progeny. And if you do it again, you get a different progeny based on the segregation and what we know. The deterministic genetic modelers are more like the breeder's equation, right? There is a formula. That formula is fixed. You can put different numbers, and different things will be spit out, but really there is nothing random about it. If you keep putting the same numbers, you keep getting the same result. There's no different answer. And we have, for example, selection gain. We have also some tools from the Roslin EIB collaboration. You have the tool from Gary. Maybe you remember the Excel file that he has been sharing. Those are deterministic genetic gain modelers. The stochastic is the one that you normally hear about, the alpha CMR. There's also a new one called MOPS, more for animal breeding. And of course, you can try all of them to explore the effect of different crossing and evaluation and selection decisions. But it's also, your decision. I want to spend at least 5 minutes to explain, how the simulation actually works in alpha CMR, in the stochastic genetic modelers, not only in alpha CMR, but in general in the stochastic genetic gain modelers, because this is something that I think it should be very clear for everyone. If you decide that you're going to design a breeding scheme, and maybe you're going to leverage from the support from Roberto or Bert or the biometricians like Johan as well, to ask and simulate something, what exactly is going on behind. So these modelers normally, start by you defining kind of an evolutionary history of a program. So there is like a pedigree that starts, is the foundation. So these pedigrees basically are used to generate some haplotypes or some sequences. So just imagine for a minute that what you simulate is the evolutionary history that, at this timing point, there was 3 founders, and suddenly after several years, there was this many founders that come from here, from here, from here. So basically, you derive a history. A pedigree can be seen as a history, right? So this is the history that you start with. You can start with a generic history. Though there is always like assumptions, but you can ask the software to generate a pedigree that is generic, or you can actually put your own idea of how the evolutionary history of your crop looks like. Actually, some programs include like maize, wheat, beef, like they have already some evolutionary histories according to what the researchers until this point know about this species. But that's where you start. You create that evolutionary history and you create sequences. So those sequences for all those individuals, basically what you are simulating is how that history happened. So you start with the founders and then you start to simulate how those sequences have been changing in the entire history because of segregation. You also put there the mutation rate. You can put bottlenecks. You can put, all that evolutionary history that you know. And then at some point, you have to start to simulate the thing that you care. And for that, basically, you start with an initial generation where you say that you drop the haplotypes in that base generation. So you say, okay, in this base generation, I have 30 individuals. And those 30 individuals come from this evolutionary history. So you just take 30, sample 30 individuals. And out of those 30 individuals, then you start to put the layer of the phenotypic stuff, right? The QTLs. How many QTLs do I have? In how many chromosomes? That's also the kind of thing that you put here, right? You put the number of chromosomes, you put the number of base pairs, the genome size. You can put everything that you know about your species to make it as similar as possible to your own crop. But when you get to the phenotypic layer, you have to specify basically what are the distributions for those traits. Is it 1 QTL? Is it 10? Is it 100? Is it 1,000? How many QTLs? That's your decision. You decide how complex you want to simulate each trait. And for those traits, you also have to specify distributions, right? This is a normal distribution, or this is not a normal distribution. It has this mean, it has this variance, it has this correlation between these traits. For example, here you can see that there is 2 traits, 2 different levels of variance. They have different genetic correlation, they have different error correlation, they have different heritabilities. The whole point is to create the phenotypes, or all let's just call it the quantitative genetics component that is behind. So for example, we are talking about 2 traits. So you have, for example, 4 QTLs, and then you have different effects for the different QTLs. So these allelic substitution effects. So basically, this is what you simulate to come up with what maybe you know about this trait. If it's a simple trait, maybe, I don't know, in wheat, maybe there is a disease resistant, I don't know, that is driven by 4 or 5 QTLs. Okay, then you can simulate a trait with 5 QTLs, with a mean, with a variance, to more or less get close to it. And also, you can specify, is this a completely additive trait? Does it have dominance? So what is the gene action? Does it have dominance? Does it have epistasis? Do I observe genotypic or genotype by environment interaction? I mean, all that part on the phenotypes, you put that layer. So again, the simulation gets as close to the reality as you have information on the complexity of the trait and the complexity of the phenotype that is expressed by those genetics. And that's pretty much what you simulate here. So just imagine that you specify a distribution and it generates, if you say 4 QTLs, well, basically it generates randomly 4 effects for that distribution with, let's say, mean 0 and variance 1. So it creates 4 values that are the QTL values for trait 1. And then for trait 2, if it's the same number of QTLs, again, it creates those values. And this is what is being used, by us and by you to address these questions. So like I said, the important assumptions that always come in any simulation are this: the gene action, the trait complexity, the genetic variance, the genotype by environment levels, and the genetic correlations. So some of the questions that you ask, normally, they don't get affected too much by certain assumptions, but some may get affected. For example, if you are simulating something related to multi-environmental trials, and you want to address that question, these, of course, will be influenced by the assumptions that you're taking in genotype by environment. If you simulate, there's no G by E, and that's the simulation, then you put in any design looks good. Oh, don't worry, use any design. But we know that that's not the right answer. Anyways, and by the way, interrupt me if there's, Yep.
From a population that is in complete linkage equilibrium. So there is no LD in there. Thank you. When we have talked to you about the simulations, you will have heard that we run what we call a burn-in, which is 20 years, for example, of historic breeding.
And this historic breeding creates linkage disequilibrium. Of course, when you start from different evolutionary backgrounds or from a population that is in complete linkage equilibrium, the outcomes might be slightly different, but the trends we're looking at and the rankings, for example, if we compare different programs, stay the same. It makes no difference. We have done that many, many times. Everyone who starts on simulations always overcomplicates these things, finds out the same results. It doesn't make any difference, at least not for the trends and the rankings we're looking at. Same thing comes in here with different effective population sizes, also something that certainly plays a role in practice, especially with regard to, do we have enough, I don't know, genetic variation or genetic variance in there? But again, you can put in an effective population size of 5 or 500. For the results that we observe with regard to ranking and trends, it does not make any difference. Just to point out, because again, this is something we sometimes get lost in when we discuss the biological or the evolutionary history, but for these kind of questions, it has almost no effect at all.
Yeah, and keep in mind that this software is also used for, or by other areas, right? It's not only for breeding. Basically, biological systems use simulations to address different things. In the case of breeding, okay, we want to check breeding strategies, but it's not the only way to use it. I wanted to, kind of give more detail because this is a very powerful tool, right? This basically summarizes more than 100 years of understanding how genetics works by the research that you've been doing, by the researchers, from the past, trying to understand how complex traits work and being able to recreate what we observe in reality. So basically at least the common phenomena that we observe in reality can be simulated. So that's why we also trust that we can simulate what can happen if we do changes. All right, so if there's, Cecile. Yes, normally actually, it depends, of course, you would need to actually tweak the software a bit more, but actually the normal situation, they are not controlled by the same QTLs. Actually, let's say that when you simulate 2 traits and you say, okay, this has 4 QTLs and the other one has 10, it actually simulates that, it puts 4 randomly in trait 1 and then puts the trait 2 randomly, let's say, across the genome. So they get some sort of independent. Of course, it cannot be completely independent because if by chance this QTL for this trait is the exact same chromosome than maybe the QTL3 for the other trait, and they are, very close, and that's why it's nice, because then you will start to see all those coupling repulsion phases that you see in reality, and then naturally, genetic correlations will be built, even if you don't want to. Of course, if you just put 2 traits with 1 QTL each, very likely they will not have a correlation. Maybe they have chromosome 1, chromosome 12, and that's it. But if you put 1,000 QTLs here and 1,000 QTLs here across the entire genome, for sure some of them are going to be close in linkage disequilibrium. But it's a fair assumption, right? That's how reality really works. Please just raise your hand if you have any question. Like I said, I'm just going over the tools that we think are really relevant for you to design a breeding scheme. The other one is the costing tools. We know that we haven't, really provided a lot to you in this space. I'm here, for example, just putting the tool from the University of Queensland on how to, cost the breeding programs. But we know that, many of the things that you want to compare or you want to try in your breeding program are cost dependent. Especially, some complex situations like the ones that Marley is working with, the potato teams and sweet potatoes, like, hybrid breeding. Do I use 1 tester, 2 testers, no test cross? All those things, they might look, clear trends, as Christian said. Clear trends, this one is better. But is it better when you put the cost layer on top of it? Because hybrid breeding is an additional crossing block. And if you put more than 1 tester, it's, a bigger crossing block. So there is, I guess, 2 options. Whether you come up with a good costing for your breeding program, or at least you create some sort of idea of how much a different decision may increase the cost. I guess both require some level of knowledge on your fixed and variable cost. Okay, so those are the tools. Just to summarize: project management, modeling, sketching, and costing. Those are the ones that we have been telling you. Try to use them when you are designing your breeding scheme, because this will for sure help you optimize it. The actual procedure, that is, I think, more straightforward. I'm actually very happy if you have some comments here. As Agnes was mentioning, we start here, right? We start in the targets. We start with clear market segments. You say, okay, here is one market segment for my program. Here is another market segment that is characterized by the target population of environments that are in this region, the type of material that I'm going to grow. Maybe it's a hybrid, maybe it's a line or an OPV, etc. And this is the type of farmer that I'm really attending. So when you put all the features that Agnes was referring to, and you have clear market segments, and you decide I'm going to focus on this, the next step is that you come up with the product profiles, right? So you have a clear description of what are those traits that you're looking for, with the thresholds, with the values, with the benchmarks, with the types of traits. So you end up with a document. And this document mostly is the most important document for all these institutions, right? These are our blueprints. This is what we're really focused on. But the next step is really to move to the designing how to address that product profile. As Agnes was mentioning, okay, we may have, depending on how much resources, how much effort we want to put, we may have different type of tiers, right? For example, Agnes was referring to tier 1. To attend a tier 1 market segment, okay, that means I'm going to put everything, okay, all my bullets for that market segment. So that market segment that has that product profile is going to get attended by everything. We're going to put every single breeder to really work to make sure that we deliver this product. So depending on what type of breeder, you might be in the early stage or very late or very at the end. And depending again what type of breeder you are, you may have a different type of breeding scheme. Your breeding scheme is your strategy, like we said, the crossing, evaluation, and selection decisions, your recipe, your secret recipe, your KFC recipe to make sure that you deliver the best product. Now, in practice, basically you get handed as a breeder, this is what we want, right? Here are the traits. This is an old picture from George Koch area. I keep saying that I'm going to change it. Keep pushing me to change it, please, Agnes. So this is the kumquat, Mickey Mouse, target product profile, where there is different types of traits. We were still actually using kind of different vocabulary, you call them differently, and that's, I think we need to stick to that one. Sorry for not changing the picture, But the types of traits. We have some benchmarks. So basically maybe the variety that is, dominating the market for that trait. The type of measurement that you need there, what is good, what is bad, one is good, one is bad, et cetera, et cetera. And what are the thresholds that you need to achieve to get that product? So this is the most important document for all of you, right? Independently of what type of breeder you are, if you are the pre-breeder, you are the population improvement breeder, the product development breeder, or the trait introgression breeder at the end of the pipeline. But it depends, of course, because depending where you're at in this process, you may have a different deliverable, right? It's not the same. Actually, if you are in this part, you actually are delivering something different to the breeding program. You might be delivering, an lead parent with new diversity or introgression if you are here. So you are giving elite parents. Take it. This has the new trait that you didn't have. You told me that you didn't have thornless. So I took some of the germplasm from the gene bank or from any accession, and I introgressed those genes in an elite parent. So now I have my elite parent, and I hand it to the population improvement breeder. If you are the population improvement breeder, basically what you are required to produce is genetic gain. Basically improved means, improved populations, that they are just getting better and better and better. But if you are in this part of the process and you are the product development breeder, you are not being asked to produce generic gains. The product development breeder, normally they are asked to just basically give those nominations of the elite varieties, right? So what are those materials that really can make it to the market or that basically meet the product profile? So these people, just send it later. If this part is still necessary, it depends on the strategy of the breeding program. Some programs try to introgress the traits from the very beginning. Some traits may want to introgress it at the end because maybe they cannot cost an entire breeding program for introgression, but they may still want to do some back crosses at the end. Maybe they have a line and they just have to introduce certain trait. So then basically they just take the same elite variety with the new trait. But like I said, this depends on the breeding strategy. But what I'm trying to say is that the objective, even though we all follow the same product profile, you may have to give a different thing to the breeding program. For example, if you are here, you probably, when you are in the meetings with the rest of the team, looking at the product profile, the question that should come to your mind is, do we have all the traits that we need in our populations? What is missing from here? What do I need to bring? What are the haplotypes? Do I have the lead parents to introgress that? If you are in this part, you have a different question for the program, right? It's like, do our population means and variances can reach the target? Because one thing is to have the product profile with the thresholds, but maybe the populations are way far from that. And that's kind of one of the questions that was being asked to Jan and Agnes early, like, okay, what of these traits should be improved and which one should not? Well, basically a trait that cannot easily reach the target needs to be improved. But if it's really close to the target and basically can segregate and reach that target, then it doesn't need to be improved. There's no need to just because you have 20 traits doesn't mean that you have to improve the 20. You just have to improve the ones that you are far away from the target. Of course, maybe there is something that is still close to the target, but you really want to invest more because, like Agnes said, maybe that's the future. That is the future of breeding. And if you are later as a product development breeder, you don't really care that much if the haplotypes were there. I mean, you need to have it already there. You just need to make sure that it really can be tested in the region, that it will be accepted, that it will basically meet all the requirements, that it has good stability. So, of course, there is different worries for different types of breeders. And like I said, maybe if you are you have a different type of introgression program, okay, basically, do we need some introgressions before the release, and do we have those traits? That might be some of the things that you may want to wonder. So this is another Mickey Mouse example of, for example, the defining, for one specific breeder, let's think for a minute in this breeder, that we all have the product profile. And we all have different targets. I have to release haplotypes and elite parents. I have to give improved populations. I have to give elite cultivars. I have to put elite cultivars with added traits. But for 1 minute, let's focus on this breeder that has to give improved populations. Well, then basically what this breeder has to come up with is also, they have different KPIs. This breeder has to come up with genetic gains. And to don't make it too long for you, because we have to produce genetic gains, basically we have to define which traits should be improved, which traits should not, which one can stay the same, and what is the rate of improvement that you may want to achieve. This is very linked with what the donors are asking for, right? Because at the end of the day, they want to see genetic gains, but always the question is, for which traits? Well, for which traits? For the improved traits. Because the traits that are not being improved from the very beginning, you said in your product profile, I'm not going to improve them. Why I should show you that I'm showing gain when it was never the case? So that's something, a conversation to have with the donors, just to leave clear what are the targets, what are your traits that are being improved, at which rate were you planning, or maybe you are seeing currently, and which ones, they are there, but as long as, the population means and variances are close to the target, you are not trying to get later than that. And well, I didn't put much about the weights, but, this will also inform kind of the weights when we get to selection indices, but I'll wait for tomorrow to get there. So summarizing again, step 1, you get handed the product profile. That's what we said. Number 2, define the target of your pipeline. because, like I said, it's not the same target. You have to say, what are you going to produce? Maybe you have to just map QTLs. Maybe if you are the discovery breeder, it's not even mapped here, right? I had to put it here. In some places, there is just discovery breeders. And the discovery breeders just have to find QTLs and haplotypes. And that is their KPI, right? You cannot ask them genetic gain. You cannot ask them a variety. They were hired to contribute to a product profile, but they were hired to just provide QTLs and haplotypes. That's their KPI. That's their target. So that's why it's important as number 2 when you are designing your breeding scheme that you have clarity on what is your target. And number 3, like I said, well, just start sketching. What is your strategy, right? You have to take any sketching tool. Like I said, we have the breeding pipeline manager. You can build something else. You can keep using Excel or PowerPoint. That's also totally okay. And you have to start writing, sketching, okay. At least my gut feeling and my understanding, of all my experience, tells me that this is a good strategy to get there. That's how you start, right? I think we have seen enough breeding happening in the last 100 years to more or less know where are the extremes, where are the good values, etc. So I'm not telling you that that this is the best scheme. I'm just telling you this is a scheme that you might want to basically come up with. Maybe you put some cost, the different decisions, different stages. It's just again a graphical representation of a more detailed thing that you normally come up with. And depending again on what type of breeder you are, you may want to come up with a strategy that addresses certain things, right? For example, you want to optimize, if you are the population improvement breeder and you want to get, if your job is to get genetic gains, improve means, and stable variances, basically what you want to, this is your target function, right? You want to optimize the breeder's equation. So all the decisions on the breeding scheme need to optimize this one. But again, as a population improvement breeder, you might not be actually interested in the entire breeder's equation. By the time that you are a product development breeder, you're almost only working with accuracy. I mean, in accuracy and intensity, I mean, you are not recycling probably. Probably the population improvement breeder is the one recycling, so you don't care about L. The population improvement breeder is the one in charge of keeping the variances at good levels. Maybe you are just here. And if you are the trait introgression breeder, maybe you only care about accuracy in your program and not even related completely to the breeder's equation. Of course, you know that the population introgression breeder might be working maybe a bit more in making sure that I'm introgressing new sources of variation. But what I'm saying is that even though the breeding scheme, you can put maybe an entire breeding scheme for the entire pipeline, it might be that depending on what type of breeder, your decisions might be guided by trying to optimize different things. And I know that we have emphasized for most of you the population improvement part, because to be fair, that's what we were requested by the donors to emphasize, to tell you just focus on genetic gains, improve means, stable variances. But the truth is that in the breeding process, there is different roles and there is different targets, and it might be that you actually don't come up, well, or you have just different type of decisions and different drivers of those decisions. All right. So the part we're about to finish, don't worry. I know that this has been long for the presentation. So once you have, you have your scheme, you have basically drafted it. Now you are at the part where we have been also kind of pushing a little bit, right? The continuous improvement part. Can you optimize this breeding scheme? Because as I mentioned, the original scheme, it might be just based on your gut feeling. It might be based on your experience of what you know of other cassava breeders, other potato breeders, other rice breeders. They gave me this recipe. Actually, I inherited this recipe from my predecessor, and I haven't changed anything in the last 10 years because I thought that he was really smart and we were doing well. Well, very likely that's the case, but can we optimize it? Can we look at the different decisions and wonder, why am I using 20? I mean, why my predecessor decided that it was just good to use 20? At what point, maybe he only had 20 materials and now I am just pretending that 20 is the best. Maybe that year when he handed it to me, he was doing 220 or 90 crosses, but actually the last year he was doing 45, and I just been running 90 for the entire time. Or, I never used blobs because he was not trained in mixed models. He was using all the time blues. I mean, should we just assume that he was or she was totally correct when they started? And well, the next part is how you optimize. Well, that's what we were saying, right? I mean, you have to bring all those tools together, the sketching, the costing, the modeling, to basically see what are the differences of running different scenarios, different breeding strategies. I mean, for example, this is, I think, from the Beans program. I don't know if you remember, Johan. We did it for Steve and for Bodo at some point, and they basically just wanted to know what happens if they were, staying at the regular preliminary yield trials at F7 or starting to go later or earlier. And basically what would happen, across years, after 30, 40, 50 years, how the genetic gain would behave if they were doing things differently, being the current scenario, the red one. And well, this is just one to start checking and discussing, but really, like I said, we need to start thinking on what are the logistical implications, how much money is needed. I know that this has been also a part that some of you are struggling because even ourselves, we were always told, this crops to earn hunger money is to basically try all these new things. And somehow, same than you, we're still trying to figure out when that money will be given so you can actually try some of these things. Because we know that some decisions are easy to implement. Maybe you were using 30, now you're using 20 parents. And even though it doesn't look like a big change, it turns out that in 20 years, you will have double the genetic gain. I don't know, just for saying something. But some things are more complex, right? Maybe you want to try sparse testing. You need to at least, the GRM, you need to try another 2 locations, et cetera, and that requires an investment. And I can assure you that we as Module 2, we've been always wanted to just also get that money for you to try the most complex stuff. And we're still struggling to figure out how to make sure that you can get those resources. But in general, if you have the resources, if you have the discussions and it turns out that, the return on investment is positive, then that means that you need to try something different, right? So basically it's fine-tuning this breeding scheme. We started sketching a breeding scheme with our best knowledge, and I guess now you don't have to start from scratch. Maybe some of the things that you will hear during this week allow you to, when you have to design a breeding scheme for the next market segment that the breeders are interested that your program can attend, maybe then you can start, okay, now I don't have to copy the same one that I used to have. Let me just base, from what I know and what I have learned and what I also heard from that training, maybe we can come up with a better breeding scheme. And last but not least, and I want to emphasize that because I think Agnes has been really steering us in the right direction together with Peter. It's not about just coming with the breeding scheme, for that market segment, for that pipeline. But we also have to show, right, how does that look in numbers, and especially what does that mean also in money? What is going to cost? This is again just a Mickey Mouse example of just the OPEX, not even including anything fixed, not including salaries, just assuming a small program, running with few parents, few crosses, small nursery, some multiplication, and how much more or less might cost. Okay, you just say, okay, look, maybe I just need $75,000 for running this very small program. Maybe this can attend small market segment, but you have to come up with that, right? Because the donors are saying that they want to know the market segments that they will invest, but we will have to present investment cases. At some point, we'll have to say, okay, or this is the way that they are picturing it. Okay, they want to invest in this market segment that is filling the needs of this population in this region of the world. And if you want to present an investment, you have to say how much money do you need to run that pipeline. So basically, you have to tell the donors, look, I'm going to produce something in 6 years in 8 years, in 10 years, and I need this for OpEx, I need this for CapEx. Of course, I'm just putting here a small program. Maybe your program requires just for OpEx, I don't know, $300,000, and maybe for CapEx or just the salaries, et cetera, maybe needs 800. I mean, that's up to you. Like I said, this is just an example to say that the direction where we're going is that they want to know how much investment is required. For example, for the banana team, they want to put a hybrid pipeline in place, and they have to say, this is how much money we need. And then, well, Jim Lawrenson was asking, do we have a table where we can show, this is the amount of money that they need, so we can take some of the CTH money and they can run that pipeline? Well, that's, I guess, where we need to go. That's pretty much it. So I will take, let's take some minutes for questions, then we go for a break, and then we come for the activity. I don't know, comments, thoughts. It's also good if there's no questions, but just thoughts in general. Yeah, Boja.
On the concept of TPEs and market segment.
Yes.
I mean,
Is it on, Boja?
yeah.
Okay.
Thank you. TPEs are more driven by the genetics, right? Quantitative genetics principles, the crop performance, the genetic correlations, and market segment driven by market. So how we integrate them together, or how do we differentiate these things?
Yeah. Let me throw some comments there. Hopefully those are helpful. Let's imagine for a minute that actually we start from scratch. That we actually don't know any about TPEs. We don't even have a pipeline yet. We're just starting with the information from Agnes. We just have a clarity that we need to come up with market segments. So when we have the market segments, she was saying that there is different features, right? You have to think about what is the product that they need, what is the region that we want to attend, what is the, is it a hybrid, is it a line, is it going to be an early maturity, kind of trying to come up with the idea of what is the product that is required. In our thinking, Boja, the TPE part, the target population of environments, actually comes as part of the market segment or the target definition. In a natural institution, let's say you start with defining what is the product, then you have to say, okay, this is the region. Just by saying in the market segment, this is the region, you somehow are deciding what is the TPE, right? You're saying this is the region. In that region, there might be many locations. But in essence, all that region is your TPE. Just look at, think there for a minute that there's no genetics there yet. We haven't actually brought the germoplasm. We actually don't know how it behaves. We just know that that is the region, and that is the TPE. There's no question about it. So the target population of environments is actually first decided by the targets, by the markets. We as technical people, we have focused too much on the genetics part, the genetic correlation part, because that's our approach. This, what they said. I mean, if you have a hammer. So, but what we are really thinking when we are talking about these genetic correlations and TPE, we are mostly thinking about consolidation of TPEs, which is not the same. It's kind of a later step. Once the targets, they said this is the region, and these are the target population of environments, the program, if they don't have any genetics running there, they don't know how it's going to behave. They just have to test. So they pick locations, and they send it there. That is the TPE. They are sending it to the TPE. The problem is that after several years of running trials, you have to take a step back and, okay, let's consolidate the TPE. How do the genetics actually behave there? And that's when you start to make, your genetic correlation studies, et cetera, maybe you figure out that actually the genetics didn't behave the same in North and South, and then say, oh, okay, these last 4 years, basically, we are not making genetic gain in the South because we have been, breeding and the genetic gain, you make the genetic gain analysis, and maybe you take the locations at the North, goes up, and maybe you look at the locations at the South, and it goes down or it stays flat. You say, okay, well, we didn't know. We had to start somewhere. That was our TPE, and we had to test. Okay, now we consolidate the TPEs. And then you can use, tools like the ones that Roberto has been proposing on because, for the TPE, the delineation or let's say at the beginning when you were deciding the targets, maybe you can use the environmental information, right? You can say these nice maps, or they look so good, and you put the material, but you don't have certainty if the genetics will behave the same completely, or really, those nice maps that you did with environmental information will have any meaning, or maybe yes, or maybe no. So you just have to try, you just have to start. So let's just keep it in that concept, like target population of environments, is your target region. It's just that it might consolidate differently after the genetics are tested. Once you can analyze it, then maybe you can partition it. And then the TPE, now maybe that these are there needs to be two different pipelines attending these markets. You have to just split. Yep, please, Elisa.
I want to.
Yeah.
I don't want to be confused. For each TPP, we need a cost, or we need to consolidate a group of TPP. The causes will be the pipeline, breeding pipeline. Do you understand? What is exactly the procedure we need to do?
Yeah, the procedure to follow, as Agnes was mentioning, well, first we need to identify what is our target, right? Before you actually invest something, I know that we have started backwards because we had programs, and now we're basically trying to figure out what we are attending properly. Now we are realizing, actually, we more or less knew that we were covering all this region, but it turns out that all this region had 10 different market segments, and now we know that 20% of our resources were going there, 10% were going there. Now we're putting clarity. But if you were to take a step back and start all over again, you first define this is the target. So you said, okay, this is the region that I'm going to attend. This is the type of farmer. This is the crop. They need this. They need that. This is what this market segment needs. That's the step one if you were to start again. And then once you say, okay, that market has been defined, what exactly that market needs, is that product profile, right? They have a clear definition of these are the traits that they need. Okay, there is the product profile. Then in essence, you the technical people come, the trait discovery breeder, the pre-breeder, the population improvement breeder. Well, we have a team. Okay, so these are our genetics. Can our genetics, meet these traits? Okay, yes, no, yes. Okay, then the pre-breeder is going to work on this trait because we don't have this resistance, or we don't have this particular adaptation, etc. The product development breeder might be one of the ones saying, okay, we need to test in this region. These are the locations that I know that are good. Normally, the best farmers are in this part. I'm going to pick some of them. And then you start the program, right? What I'm trying to say with respect to Boja's question is that when you start the breeding program and you put the genetics, you don't know for sure what is going to be the behavior of the genetics. You just say that is the target population of environments. But the target population of environments, let's say that is kind of, is naturally a decision of defining the target, defining the market segment. So once you are there, it might take you several years to understand if the genetics that you put there were actually behaving well in the entire region. It might turn out that maybe the elevation, north-south, something was really making difference. And then, I'm getting to your question. So what you actually created was a breeding pipeline, right? When you actually took these 4 breeders and said, okay, let's work together, that's a breeding pipeline, right? You're going to make this breeding pipeline to attend that market segment in that product profile. And then, okay, if it turns out that the genetics were not behaving properly because they were, having different genetic correlations, when you put the blobs or the estimated or the breeding values from the region 1 for the same material in region 2, and let's say you have a completely negative genetic correlation, well, it means that when you are selecting something good in the north, it's actually the worst in the south. So then you have to just create 2 breeding pipelines. And then it's up to you. Maybe you say, okay, we don't have enough money, and we are just going to focus in the north because that's what really, is giving us more in terms of, attending our stakeholders, the farmers, attending poverty, attending undernourished, farmers and families. Okay, and then you decide just focus on the north. If you have enough resources and you think it's worth it, okay, then let's create another pipeline. But as Agnes said, maybe you don't need to create an entire pipeline. Maybe you just need to create a different type of an introgression pipeline. Maybe they can take some products and transform them maybe they just need another trait. But maybe, but you know, if we are in that situation where it's completely negatively correlated, it's very difficult to just leverage from the other because the genetics don't behave well. But if there is no such an extreme negative genetic correlation, and you know they are just relatively related, okay, maybe you can just put something, not an entire pipeline, but at least maybe use late stage testing, or maybe just introgressions at the end, and so on. Does that make sense, Elisa? Yeah.
Yes. Finally, I have I think what is exactly the role in the breeding program? Because in the discovery gene, you mentioned there are two ways probably. The breeders do discovery genes, but in our case is the pre-breeding is a team who is working in wild species in order to discover a new gene. And this is a half time. This is because they started to work with the wild species, and they need to time. Probably, I don't know, is this part of the breeding process, or they need a special?
No. It's part of the breeding process, but it's actually the pre-breeding. The problem is that, well, it's not a problem. It's just naturally occurring. And I will let Sarah, on Thursday to discuss more on that area and have some discussions with you, so we can, just talk to each other and come to an agreement. But the thing is that in the area of pre-breeding, at least some of the projects that I was working with, they used to have like different types of populations, right? I mean, there was kind of some easy introgressions, let's say, where they have the elite parents and there is just something in the breeding program that is really good and they have the trait, and boom, they can transform it and give it back to the breeder for the population improvement and product development. But there's always these long-term experiments that I actually think are worth it. Don't misunderstand our perspective. It's just that sometimes maybe some of those traits are easily available in something that is not so wild. So those can be, kind of easily given to the population improvement breeders. But there is also very worth it long-term experiments or long-term projects where you may want to take something wild and introgress it. But you may want to really think twice if that is really the solution to your program, right? Because if they are telling you that they have a product profile and they need to release this variety or they want in 10 years with this trait, and the first thing that you look at is the wild material, well, you have to be honest with them and say, well, this is the only way, or maybe no, maybe just because you really want to explore that wild material, maybe there was in another more elite material and it was easier to introgress. I mean, that's kind of your decision, but I don't want to also discourage, and I think that's sometimes discouraged in general in the conversations with the donors on these long-term experiments, because some very useful things come out from those wild materials. It's just that, of course, it's difficult to say in a 30-year period, right? It's until very later. So you may want to still do it, but maybe allocate less resources accordingly because it's not the priority of the breeding program. For example, I remember I was telling Marley once, when I was working in the blueberry breeding program in Florida, they had these low-chill varieties, right? That they can grow in Mexico and Chile, and now you see them growing around the world. But 30 years ago, that was not the case. This was a 30-year project where basically a breeder said, I'm going to take the blueberries that only grow in the north, they don't grow anywhere else, and I'm going to cross it with these, not only wild, another species to introgress the low-chill genes, because this species that is the same genera, but is not the same species, basically can grow in the tropics. They cross it, 30 years of back crosses to basically bring it back to be a blueberry, but being able to grow in all the tropics and subtropics. It paid off. I think it paid off, right? Now you can see them growing. The industry is huge. I think people hear about blueberries like more than 30 years ago for sure because it grows everywhere. And it was a long-term project. But how to justify those expenses, I think sometimes you just have to make that case clear to the donors and say, this is a long-term project. This will not be our priority for the breeding programs. When we work with the breeding programs, we will look at material that is, closest, maybe elite in other regions, but it's unadapted. Maybe we just have to, make the adaptation to that particular elevation or particular things. I think it's mostly about clarity on the targets, more than, saying that this one should not be done or should be done. Yeah.
I think it's possible clarify this part in the user discovery gene for us, or because it's a manner we think, okay, we can use the elite clones of the pre-breeding material. Probably it's possible or no, but it's true because we need to invest time in have this kind of elite material in order to incorporate in advanced materials, the breeding program.
No, yeah, it takes time for sure. Like I said, it's just a matter of really talking with the rest of the team before taking that decision. Yeah, I will let Maria Fernanda to get there. Because, like I said, if you just take that decision, basically you are taking the decision for the entire team. Maybe the team really needs that trait in 5 years. And maybe there's a way for you to find that trait in other source and not necessarily that really wild or a completely exotic or a different species. That can be, maybe that trait is something completely new that doesn't exist. Okay, that's for long term. You also need to look at the future, but we need to be careful. Yeah, Maria, do you want to share the microphone?
Yes, just looking to that kind of traits, we decide to have like an approach to decide what we could do and what we can't at all. And it also depends on how it's working in an elite background, because sometimes those traits are completely dependent on the background.
Yeah.
So we decide to have at least 4 or 5 elite lines to cross everything that might be a donor for a new trait or a new QTL, and decide if it's working in a segregating population in that kind of background, then we will make the effort to do integration. So if we are not increasing somehow the performance, then, or at least in a really measurable range, might not be a good idea to start working with that one. But it also depends on the size of the team, because we really have to prioritize in our team what to do and what not to do. And that's also an approach. But I also have a question from the last slide that you had. So it's about the sizes of the programs, because it has been very, for example, we have programs with 1x size, and we have, between 25 and 30 parents, and we are going to decide how many crosses are we going to do and how to advance. But I'm not sure if that is also included in the simulation as well, and we can manage to understand how to make a bigger or a smaller program with still a good genetic gain for the target.
Yeah, there's actually a lot to discuss in that part, and I think that's one of the first topics that we touch on tomorrow or Wednesday. So yeah, let's wait for that discussion on optimal program size. We're going to get there. For now, it's just something very general, but I agree. There is actually some subtleties there. We addressed some questions, but actually, while we were addressing these questions, we realized that there was other things that have not been addressed, and we want to discuss with you, because we are not only coming to give you the summary of the results, that things that we simulated and that Roberto simulated and that Bert simulated and that everyone simulated, but also to see what else needs to be addressed. And also, for you to share actually your thoughts and comments and ideas with the rest, because here we have also different types of points of view, right? I mean, we have rice, we have wheat, corn, forages, potatoes, cassava, I mean, different types of crops. So I think we all have different perspectives, and you will see that in general, I think we try to address those questions exactly for the different types of crops that we were working with. But yeah, let's, like I said, let's make sure that this is a retrospective look at what we did and what you were asking and your ideas. So, but yeah, we'll get there to the size of the program soon. Yeah. Yeah, please go ahead.
But I have a question regarding if the combinability is also a parameter in the simulation, because it's not it depends on the combinability of the different parents that you are selecting might change, and that could influence the genetic gain. It's going to influence the genetic gain.
You mean the ability to cross one parent with the other?
Yeah, and how good, like how they will perform as parents, because you can find very good lines that then when you use it and recycle them as a parent, they are not going to increase the value
Yes.
of the population.
Well, that's part kind of the simulation, right? That we have always known that not all the elite materials are actually necessarily the best parents. Sometimes some of those maybe just show heterosis. Maybe they are just showing that they are really good, but once, they segregate, they actually dilute. So that's kind of built in, but that's why we need, to kind of put the right assumptions, right? Levels of dominance, no levels of dominance. In some of the simulations, we actually also take into account that there is different sexes, right? I mean, there is males and females. Not everyone can cross with everyone, or there is different maturity times, things like that. But sometimes it's not worth to look at that trend unless, it's really necessary, depending on the question. Like I said, the assumptions are based mostly on the question. But yeah, in general, that fact, I think is built in. It's kind of natural, just like I was explaining to Cecile, just like when you simulate multiple QTLs for different traits, and it's not that you have to create a genetic correlation. It's natural. It's there. Somehow also, when we simulate, we observe that sometimes you get an individual that is, kind of later in the distribution for some traits, and you pick it, and that might be a good product. But actually, when you use it as a parent, it's not necessarily that it's not good, but it might be that it was only good for a couple of traits. And when you look at it as a whole, to be a good parent, and you take into account the rest of the traits, it turns out that it's not necessarily the best of the best. But of course, it depends on how do you weight the traits as well. But yeah, let's also get on that one, especially when we get into the indices. Mm-hmm. Any other thoughts, comments? Yeah, please, Mokhtar. There is a microphone there, so Mokhtar can, because he was sleeping the entire presentation, but now has a question. Just kidding, Mokhtar.
Yeah, exactly. It's because I woke up and I don't understand this time.
Exactly. Can you repeat that one? Yeah, go ahead.
No, actually, I have a question, but it's still not clear in my head. So I will try to make it clear. I'm just thinking about the cost. Like if I have the costing tool, and I know the cost of all my operations, but then I have my budget, and say I have, for example, for my preliminary yield trial, I'm testing in 5 environments, just an example, and 5 environments with different costs. And I know that my budget is not following. Is it possible to use one tool that says, oh, reduce this environment, like remove this environment and increase your plot size on the rest of environments so you may have the same genetic gain? So like trying to reach the same genetic gain but with a different budget, like a lower budget. I don't know if is it a way to make that connection?
Yeah. First, yes. I mean, you can make those connections for sure, right? I think once you actually cost your program, if you figure out that actually you're in red numbers, that means that you have to drop something or change something for sure. I guess that's what you're trying to say. I guess the question is, do you drop something or do you change something? Well, I would first think, first see if I can change something. And I would say that's where you have to leverage kind of, well, of course, the expertise from everyone across the CG, your biometricians, your QGs, and say, look, this is the way I'm currently doing things. And basically, my budget tells me that I'm, 10% over. What can I change without affecting? And then you have to say what? Without affecting what? Your genetic gain? Without affecting your product delivery? Without affecting, there's ways to, to address kind of getting the same output with less cost. That's the optimized exercise, right?
Yeah, I'm asking because I have worked some years ago on selection gain, like the package you showed already. And the idea was to work with NARS in West Africa, trying to have an estimation of the field plot, like how much one field plot costs. And all the costs of the breeding program were reduced to a field plot. So even DNA extraction cost maybe 1 or 0.5 field plot. So we were feeding like the program with field plot costs. We know how much cost a field, but we don't talk dollars to the program, but just the field plot, and give it a budget. Like I have a budget for 20,000 field plots. And then say, okay, I want from F1 to F5, and I have this budget, and it would allocate differently the number of replications, the number of locations, and then at the end you will see that if you play with the budget, it would at the end give you the same, more or less, genetic gain, but just playing with the different, let's say, sizes of your program.
That's the question that basically you all asked. I mean, everything was always related to cost at some point, right? I mean, of course, we are always presenting maybe those genetic gain pictures, but we always try to, link it to cost. So let's wait, for example, for the MET presentation from Christian and see more or less if that makes sense. But yeah, that's the whole point of the optimization, to make sure that we can do the things better with the same cost, or at least, equally with lower cost. So it's depending on your approach. But yeah, that's a good point. Let's see if we can take a look. Brenda, you want to say something? Break time.
Other part, that actually sees the indirect costs and all of that. Is that something that you guys are also going to include here? Or is there discussions with those services, the admin, the finances? Because everyone needs to be aligned, because we're having discussions here, but we really also need to be talking to the financial people that are making the numbers, because the example that you gave right here, they don't do their cost based on plots and So I'm wondering if we're missing a step, right? Or a part that we're not discussing, because they're having their meetings of how much indirect costs they're going to charge us, of how much everything. And here we're discussing of how much our programs cost.
Well, you have
those are do you know what I'm saying? So I think there's there's this communication that's missing between.
I would like that maybe some of these people, some of these breeders actually give their perspective, because, you're right.
Because they are, I know they are having their meetings, figuring out our
costing a breeding program is actually quite complex, right? And it has a lot of things. But actually, I also honestly don't think that the breeder is the one that should be doing all the costing part. I think that's why you have administrative and finance people.
I just think there's there's some
I think this connection.
I think if there were more
I saw
communication between the two.
I've seen breeders, coming up with approximate budgets for their operations for the year, but I've never seen the breeder being in charge of the entirely costing for the tractors and I've never seen that until I got here, but I guess it's because the breeders are asked to come up with those numbers. And what I've seen, maybe I'm wrong, and that's why I'm asking that they come inside, say something, is that the different groups in the CG doesn't seem to be clearly connected. It's like they do other stuff and we do the science. But I don't know. Someone wants to say something to Brenda's comment? There is microphones there, please, because otherwise.
To think is we need to have a contact with financial area and also the logistic, because it's impossible to work alone. And if we don't align these points, it's difficult to achieve our goals, because you request something to logistic and have time, 2 years for a laptop or a smartphone, you can implement it in your process. Or example, in SIP, 1 month ago, we are changed of the service for the personal season personals, and the rise of price for these people is three times the cost. It's so right, so high, and it's not mapped in our budget, and they are definitely impact in our activity now. It's a bigger problem. But this is the human resource take us along the decision. And some say, tomorrow the cost of the personal is triplicate the cost. And we say, what? And how this is a bigger problem. So the idea is that the ones here have a huge challenges in order to to go for the final goal, because it's not only the breeders or the statisticians, no, it's everybody need to be conscious about focusing the business, in the real business. But don't talk. I think we need to talk more with the financial area and the human resource and logistic, because sometimes it's disconnected with our activity. Sorry, but
No, I agree. I think we all agree with you. I think, but just to let you know, I mean, this training is being recorded and being being broadcasted alive. So it's live. So
That's good.
just for you to know,
They will listen.
people might be exactly watching us right now. That is not
Yeah.
in this room.
Just a quick comment. Yeah, when we prepare a budget for any project, we definitely include everything.
Yes.
Yeah, that's.
But usually you include everything, but it's not the entire team that's there. Because, for example, we have a crossing facilities or a crossing team. So it's 3 people. But those 3 people, you cannot divide it into 4 pipelines or how you are going to divide that cost. And then when you make the entire cost, for example, for me that I have all the cost in the RISE program, physiology, pathology, genetics, whatever it's in there, it's up 80% of personal plus research and technical support, plus IT, and it's 80% of the budget. So then you have 20% for operations. So, or it depends on the projects, it could be 70, 30, but it's huge if you measure that and put that cost into the pipelines.
That's why those costs look really
But
small. But
also, if then you try to reduce it, like, okay, I'm going to do just 2 pipelines, then you have people that was working for the 4 pipelines. So now you cannot divide that person into
4.
half and just pay for half of them. So I think that's mostly the trickiest part of all this, the costing, because we have the cost in operations. Even in capital investment, we have the costing, and we can divide, and we can make the charges that we need to do to improve again machinery and mechanization. We can do that ones, but the other ones, and sometimes they don't depend on us how much they will change from year to year. So in our case now we have hybrid work, so we have to pay an extra fee for people that staying at home. So working from home. So and we never decided to do that, and that was not part of our budget. So if you are recording, that's good, because they might listen.
yeah, actually, the Gates Foundation is calling me, so. No, that's fine. Yeah, I think those are good comments. Thanks, Brenda, for bringing that up. So, if there's no more comments or questions. Yes. Yeah, like a baseline.
The real what happened in each product profile, and it's like when you say sincerarse in the English, I don't know. Is to be honest about the real requirement of the technician and the staff in the centers, or only probably we are doing a lot of work, and we need to be more honest and focus in a specific objective, because the resource is not unlimited. We need to focus in the resource finally. I don't know, because we have to wait.
Well, I hope that actually everybody sees this as an honest exercise, just like with the genetic gain, and we will get there. But when we said it at that moment, it was not really about showing off, that we're making 3% or 5% genetic gains. I mean, that was never expected. It was mostly about creating these processes, aligning, being able to measure something, instead of focusing on, oh, look, I have 10% genetic gain. I mean, they actually didn't look at those numbers as you expected to give the funding. That was never the case. Actually, it was just about, okay, who was actually aligning? Who was actually, providing numbers. So yeah, I hope that when it comes to costing, people also feel the same, that they are just putting the numbers without. Of course, we know that this is not going to be optimal. It's very far away from what everyone would like to really have, like you said, these 2-3 times more cost personnel. But you have to start somewhere, right? I don't think we have currently a project for costing the breeding programs properly. I know that has been asked by the foundations and the donors just to cost it, but I don't think there's anything properly in place. So I will not really say much. I prefer that to leave that for another initiative. Yeah, excellence in costing. Let's leave it for that to exist. All right, so let's go for the break, 15 minutes, and then we come back at 3:50 for the exercise in the computer, and then we call it a day and start later. Oh yeah, we still have dinner, sure. Sounds good. 3:50. Right. So like I said, let's use the last hour just to make a quick exercise with the breathing pipeline manager. I know that you know it. I know that you hate it. Some of you love it. But let's just clarify some things there. I mean, this is the opportunity for questions, for comments, for feedback. Mostly feedback, I guess, at this point. So, we have the software developer ready to start improving the tool. So we know to gather as much feedback as possible before we start paying this person for addressing everything that we want. So I would like us to spend 1 hour, just trying to don't fill an entire breathing scheme, just a small portion, especially for the ones that maybe haven't used it before. I think will be really nice. We were talking about sketching tools, blueprint tools, a way to document basically your breathing strategy. So if you go to your Dropbox, you will see that you have this presentation in day 1, and you can copy this link just to open it in the Firefox or Google Chrome, wherever you can open it. But before, I'm just going to give a quick summary of this tool, 10 minutes, and then we can start giving it a try. But in the meantime, if you can start, just trying to find this presentation, get this link, and put it in Google Chrome, that will be, a good step. Okay, so I think this part, this slide, it was about the cassava stage gates that I think it was Ismail or Xiaofei sharing. And I guess I'm just trying to go to this slide because we talked about, how the different stages or the stage gates that we've been talking about, fit in our conversations, stage 1, 2, 3, 4, 5, 6, 7. And we've been talking about how there is some breeders that work in the population improvement part, some others in the trait introgression, some others more in the product development. And basically, the breeding pipeline manager tries to create a, kind of a framework or a place to store data on how do you conduct some of these stages. Like I said, it could be that all the breeders work together and they just have a single breeding scheme for the entire pipeline. Or it could be that maybe Maria Fernanda wants to do her own, and maybe the one that goes after Maria Fernanda makes their own breeding scheme. But I think in most cases in the CG, anyways, we don't have that many breeders in a pipeline, right? We have 1 to 2. So anyways. So quick clarification, in case you were some of the people that actually came to this question when you were trying to use the tool. You have noticed that in the tool, once we open it, we gave an option for the users to basically select crossing block, stage 0, stage 1, stage 2, stage 3, etc. And there were several comments on how this actually overlaps with the stage gates that Peter has been talking about, product design, trait development. I mean, what is the stage that we should be putting? Because we normally refer to stage 1 when we're talking to you like the first stage of evaluation. So let's make that subtle difference, right? That when one thing is the stage gates of the breeding process, another thing is when we have been talking about the stages of evaluation of your breeding program, of phenotypic evaluation. So at the end, it's up to you how do you use the naming convention. For us, as long as you have clarity on what is the preliminary yield trial for you, I mean, because maybe that is a stage 1 for one program, a stage 2 for another, et cetera, et cetera. And in the stage gates, this preliminary yield trials actually is not until stage 4. But just kind of is not the same, right? One is the stage gates of the breeding process, the entire breeding process. And on the other side, I mean, on the other hand, you have been using the word stage to refer to the phenotypic evaluation. So the only thing that I guess I'm going to ask you is to make that subtle clarification when you use the word stage, if you refer to a stage gate of the breeding process or a stage of phenotypic evaluation. And that's it, right? We don't have to fight about what is what or et cetera, et cetera. So normally, what we are putting here or in the breeding pipeline manager, we have been referring to the stages of phenotypic evaluation. But if you want to, and that's where they have kind of different stages between the different crops. For example, I think Dirks put IITA and C out there. All right, so were you able to open the PDF with the link? Okay, so let's copy the link. Like I said, this link into Google Chrome. And then let's open the breeding pipeline manager. You will see, and then we're going to go step by step, really little by little. But you should be in here. And if you already signed up for it, well, you just have to put your password. If you haven't, then you have to click here saying that you don't have an account and you want to sign up. It's not going to ask you for a lot of information, just your name, your institution, create a password, and that's it. Then you can immediately connect.
And just a quick comment, it's not your EIB account. So if you have an EIB account but not signed up to this breeding program manager, these are two different things and it won't work.
Yes, so some people that thought that this is, like if you already have a Toolbox account, is the same account. So no, the Toolbox account is not the same than this account. So you have to create an account. If you haven't opened this before, you don't have an account, just to make it clear. But, yeah, so don't use that one. Just, Yeah, that's what Kristen meant. Like if you already had an EIB account in the Toolbox, it's not the same than this one. So just create an account if you haven't done it before. If it turned out that you already worked in the past with us, you may already have one. Elisa. Oh, okay, and then that one should work. Yeah, that one should work. So just put your password, your email address. Take a couple of minutes to sign up. And then, you should get this screen. Without all these pipelines, of course, probably just one for you. This is just because I have the rights to see, who is in the system. But in general, you should see kind of this screen. And then if you need any help, just raise your hand, and then Dorcas, Christian, or Marley will give you a hand. So what I'm going to do is to just give a quick summary on how this tool actually works, right? I just wanted you to at least sign up so you can see, or you can follow easier. But you're going to see this screen once you sign up for it. And basically, what this allows is just to formalize what we have been talking this morning. Market segments, product profiles, breeding schemes, kind of have clear targets, and then defining a breeding pipeline that will attend those market segments. So we're still in the process of making adjustments with the help of Peter and Agnes, because same than you, probably we took a backwards approach, where we first define the breeding pipeline, and then we say the market segments, when it should be opposite. You have to create a market segment, and then you create a breeding pipeline for it. Still, we're going to start there. Currently, the tool basically has a couple of buttons at the top. One to basically, these little 3 bars is just to basically decide which of these columns you want to see. not really relevant. It's just if you feel that your screen is not big enough and you want to give more space to these columns, nothing to worry about. Then you have this download button in case you want to just download a table with all the different names of these breathing pipelines, basically that table. You may have something, you may not have anything, depending on whether you work on this before. But the important part is that this plus symbol will allow you to create the unit of a breathing pipeline. So if you click on this one, basically you will have a screen that allows you to decide, okay, this is the breathing pipeline that I'm going to work on. And one of the big advantages is that even though you might be the one creating a breathing pipeline, when you click in this plus symbol, you can actually share this breathing pipeline with all your team members, right? This is a tool where you can actually play with your team members because there is like a share button. Once you create a breathing pipeline where you just say what region is attending, what continent, et cetera, and eventually you will actually say which market segments, but eventually. Basically, once you define this breathing pipeline, you can share it, and basically the same information that you see, your team members can see it, and they can modify it. And like I said, it could be that maybe the 4 breathers, the integration breather, population improvement breather, the product development breather, they basically have the same pipeline. They have the same document. They just say, I feel this part, you feel that part, you feel that part. So that is step 1 in the breathing pipeline manager, to create a breathing pipeline. So if you want to give it a try, don't worry, you can delete it later. So just click on the plus symbol and create something. I mean, this is just a Mickey Mouse example, right? Maybe just differentiate it if you have another one. Yeah, Lisa, please. What I would recommend is that first, of course, you define the market segment. And that market segment may have, let's say, 1 or 2 or 3 product profiles, right? So you have the market segment. And I'm going to get there. But let's say you have that market segment, the product profiles. And in essence, because normally we work in a one-to-one relationship, that's why we didn't worry too much about starting with the pipeline instead of starting with the market segment. Because initially we had this idea that this breathing pipeline will actually attend this market segment. But also we noticed that in reality, many breeding programs have a pipeline that attends multiple market segments. That's why at the end of the day, it didn't turn out to be that bad, because this breeding pipeline actually can attend multiple market segments. So that's why maybe I'm just going to go a little bit further and then I come back. But for your question, so when you define a breeding pipeline, you may want to define, let's say, first the market segments. So let's say that you define 3 market segments that are being attended by these breeding pipelines. So they are nested. They are nested in a breeding pipeline. Yeah, I mean, everything is possible, right, depending on how do you see it. But what I'm trying to let me just actually go to yeah, please, Rosa, go ahead. Yep.
But I think it has 2 market segments, because one is focused for East Africa and the other one is focused for Latin America.
Okay.
But then I have another one for a program that it also has East Africa and Latin America. Question, because I have different, with Megathyrsus, the product is almost the same.
Yep.
It's just the region that is different. But with the I have different traits, specific sets. So would that go into the market segment or the target product profile?
The different traits will go in a different product profile, right? But basically, I think they probably also map to a different market segment, isn't it? Because, well, the region and also is not, maybe let's get there. Maybe I'm just going to open an example. So let me look for maybe a, one that is not from someone that I can mess up with. Oh, I didn't know that there was that many users already. Okay, good. So you see, for example, that I have here a Mickey Mouse example. The species is Mickey Mouse in East Asia. And we have 3 different sections, right? One for market segments, one for product profiles, and one for breeding schemes. Essentially, when we said this pipeline will serve a given set of market segments, is because this breeding pipeline also has some sort of base germoplasm, right? I mean, this pipeline has this germoplasm. So like Agnes was saying, I mean, the first thing that you will have to define is the market segments, right? I mean, this is really the target. I would say even for a minute, forget that we are in a breeding pipeline. Just think that this is the step 1. You have market segments. And then once you define the market segments, you should be able to move to product profiles. And you don't see it yet. I need to look for another example. But you can link and say that this product profile belongs to a market segment, right? It might be that as we put in one of the figures in the maps, that region, maybe there is more than one product that can fit there, right? Maybe there is 2 products that can fit, and then you have 2 product profiles. The thing here is that normally our breeding programs in the CG don't have enough resources to create lots of breeding pipelines, right? So it's very common that this breeding pipeline will serve these market segments and all the product profiles nested. So I guess maybe what might be useful is to just put a picture of how everything is nested. How everything is nested in what? I would say market segment is the biggest unit. Product profiles are nested in market segments. But then breeding pipelines might cover maybe more than one market segment. So even though ideally it would be one-to-one because it has to be very focused. So consider market segments and nested product profiles here. Then the breeding pipeline comes and it could attend one-to-one, but in reality in the CG is taking more more market segments at once and all the product profiles nested in the market segments. So I guess, like I said, somehow everything is possible, but we feel that that is the more natural way for the CG programs to operate. Being realistic, they will never just attend one-to-one. Well, maybe I shouldn't. We have Agnes here as well. And I know that we would like to be one-to-one, but in reality, I think you will always have spillovers, right? And just by having spillovers that are going to other market segments, you are basically covering more market segments. So that's kind of the structure that is somehow explained here. Like you have breeding pipelines, and then this pipeline might be attending here with one market segment. Maybe for this other, for ASRAT, this pipeline is also attending only one market segment. It might be that there is more, but maybe in that moment, the breeder only put one. Or maybe they really want to follow, the suggestion and say, from now on, I only serve one market segment. But in essence, even though you only see one market segment in some of these programs, there should be more, right? Well, you could put more. You could put just add, and it's going to create another line where you can say this is another market. Maybe instead of focused on the, I don't know, maybe this one was focused on the semi-fertile soils. Maybe the next one will be focused on high fertility soils or something like that. And like I said, when you look at the product profiles, you can link them and just select to which market segments this product profile belongs to. But maybe I shouldn't, go so quick further, especially because of the people that haven't used the tool before. Let me just take a step back, finalize very quickly this presentation, and then the ones that want to give it a try, please do so. So yeah, like I said, we first create a pipeline. Step 1, you name it. You click in the check mark. Yep. Well, yeah, the breeding pipeline, I would say that's a good question. where it works or where it's attending. I would say that maybe this part is not that relevant to worry about, because the important part is to say that the market segment has clarity on which region. But for the breeding pipeline, it might be that actually attends more than one region. So maybe we can use it as the part where the program is located, right? Maybe you can put in Colombia, like it's in Latin America. And then the market segments will say East Africa, South Africa, Central Africa. Good question, Shofei. And like I said, if you have a suggestion like, okay, let's maybe add something else, please let us know. And okay, so once you create the breeding pipeline, then you will have those little icons. Like I said, these 3 icons represent the market segments, product profiles, and the breeding schemes. So the idea is that you start with the market segment. So you click here, and then this will display a new table that will allow you to basically say how the farmer is, what type of environments I'm expecting to face. Is it a hybrid? What is the texture of the material, et cetera, et cetera. Some of the things, well, not some of the things, basically the fields that Agnes was referring this morning on how do we define market segments. So we have to reduce it now because at some point we heard that we wanted to describe the client, but I think this has gone in a different direction. But more or less, basically, this defines the 7 or 8 points that Agnes was referring to on how to define market segments. So, like I said, just look at how many fields are here. Not all the fields apply to all the crops, so you can just leave them in blank. But just think about all the possible combinations that you can actually make with all these features. That's what I was referring this morning. Like if you just make all the possible market segments that you could cover, you can end up with actually thousands just for a single crop. So how do we keep this focus? So basically not trying to create every single combination, just trying to go through the exercise that Agnes said. You go with your multidisciplinary team, you define the market segments, and then once you define the market segments, you come and put it in a database that these are the market segments. So long story short, don't try to define today your market segments. That's not what I'm trying to tell you. This is not for you to define market segments. You have to define market segments with a multidisciplinary team. Once that is defined, you look for a tool to basically document that. And this could be one option, like I said. So you can put 1, 2, 3, 4 market segments. Like I said, the ones that you said, I'm going to attend with this breeding pipeline. But step 1, work through the process that Agnes explained this morning. And then, like I said, then you can add some product profiles. In this second icon, you can click the plus symbol, and that will basically, again, display a new little window where you can name what is the name of that product profile. Maybe it's the product profile X or product profile Y. And then you can select that product profile to which market segment belongs, right? Because we said that the first thing is market segment. Then you have to say, okay, this product is for that market. But maybe there is 2 products and both products are for the same market. Or maybe you have 3 products and each of these products is for a different market segment. So just trying to create the links. So behind in the database, there is some metadata that it creates the links. So at some point, if the biometricians or someone else wants to extract this data, there is metadata files that can link, okay, all those market segments are linked to this pipeline, and these product profiles are linked to that market segment, and so on. But this is just the naming part, right? This is just to say, I have a product profile that is named product profile 1. But the actual product profile is that description that Agnes presented to us with the traits, the thresholds, the benchmarks, and that it can be actually created by clicking on this other symbol. That when you actually mouse over, you will see that it says table for product profile or something like that, or open product profile traits. So let's start there. Let's try to just create, for today, create a market segment But again, don't think that you're going to define it in reality, right? That is defined with a multidisciplinary team. But here is like we're just going to pretend that we already went through that process. We're going to create a market segment, and then we're going to create a product profile for that. Well, again, just passing the product profile into the database, not creating it. So please create your breeding pipeline. For example, I'm going to create this one. I'm just going to say region, North America, species. Again, I need to delete it next time. Mouse. And then I click on this save. Okay, now unfortunately it goes towards the end probably. So I need to go to the last page. Or maybe it's good question. Do you see if it's sorted by something? Sorted by, I have created so many. Would it be in the first one? Oh, yes, actually here. So it goes at the very beginning. So in market segments, for example, you click on this plus symbol. So please give it a try. Not complicated. So now you say which region this market segment is going to work on. Maybe it's East Africa. I'm going to, for example, skip the rest of the client description. But maybe I said, okay, I'm going to work on temperate climates. And maybe in subhumid, I don't know, forest. And also if you identify any level for these variables that is not there, just write some notes, please. I mean, what we want today is actually feedback to improve this tool. So if you can, just write, Eduardo, you're actually missing this type of vegetation, this type of environment. Please give it to us. And once you finish that, then you can click on the Save button. Is anyone having trouble, being able to create? No? All good? Alejandro, were you able to make it work? Okay. Good, good. For the rest, I know you already went through this exercise so many times that you don't have any trouble. But we have some people that haven't done it before. And then, for the same pipeline, then you can go to product profiles. You can see how I'm clicking here. And then again, I have to click on the Add button. Maybe I name it Target Product Profile X. And then I link it to the market segment maybe that I just created. Maybe you can have more market segments. And then you just click again on the Save check mark. Cecile, I see that you're having trouble. Is that good? No? All good? Great. Maria Fernanda, yeah, please. Feedback. Oh, you mean this part? Yeah, so like we said, it could be that we have these tiers, right? That this particular market segment can only be attended by tier 1 or tier 2, tier 3, tier 4. So that's kind of the part that in this moment of the development, we're trying to reflect. Like, this pipeline will not do any trade introgression. I mean, this market segment will only be attended I don't know, by the product development, right? So maybe let's say that actually there is no introgression here. Or no, it was the other way around. Currently it says that there's nothing here. Yeah, so maybe it's only going to be product development. We're going to take or leverage and just make some testing. So that's kind of the part that we wanted to do. Can you say maybe the question again, Maria Fernanda? Okay. I don't think, I see your point. So you have a single integration program that is attending different market segments. Well, I would assume that that's not a problem, right? I mean, here we're not actually saying who belongs to who in terms of the integration. But maybe to make it clearer moving forward, you might want to create kind of an integration pipeline separated from this one, right? Just to say, here I put all the market segments that I'm attending, and they have trade integration, but the pipeline for integration is kind of separated because it's attending across all levels. It could be that one way. Cecile? That's a good point. So what you're saying is, yeah, you could, because actually you can copy exactly this market segments table. Let me show it. What I would do in that case, Cecile, is that let's say that this pipeline only represents the population improvement, the product development, let's say that part. What you could do is just to take, for example, this one and basically copy it, and then you will have all the market segments there. I mean, all the same information, but now the only thing that would change is that maybe instead of naming it, for example, I didn't put any name, but maybe this is specifically the integration pipeline. Yes. Well, you don't have to, because like I said, you just copy paste it. You don't have to do it yourself. You just click on the button that is for copying, right? For example, when you can see that many of these things create duplicate. So you don't have to really do it, manually. Well, yeah, manually, but you don't have to fill everything. But if you come up with a better idea on how to work that across, because I guess that's going to be common, that many of the integration pipelines will work across many of the efforts. So yeah, Dorcas, any thoughts? Yeah, that's a good point. That's another option. You see, Cecilia, maybe you don't have to create many breeding pipelines. It's just the same. Of course, now you have, actually, let's work on this particular example, right? Actually, I'm messing up with birds. Sorry, bird. Let me actually open mine. So, yeah, but let me just address that. Let me just address the question from Cecile first. So let's say, for example, Cecile, that you actually have 4 market segments in that breeding pipeline. And then you decide that all of them have integration, or 3 of them. I think the part where you can differentiate as well is, you keep saying that we are working under the same pipeline. We have the same market segments, but the part where you can change is to have different breeding schemes, maybe. You can say that you have a breeding scheme for population improvement and product development, and you have a different scheme for the integration pipelines. So that way you say, okay, this is, I don't know, this is the 3-year line pedigree scheme, and let's say that this is attending this market segment and this market segment and this market segment. And maybe you said this is just population improvement. And maybe you create another breeding scheme, and maybe this is actually longer. Maybe this is a 6-year line, single seed descent, introgression, pipeline, and maybe it's also attending. This is interesting. Yeah, you cannot select the others, because I think that was kind of the original focus, that one scheme can only attend some segments, the other scheme can only attend some segments. So what we can do is just to allow the users to give them the freedom to say that one scheme is cutting across everything without affecting the rest. Yeah, that's good feedback. Yeah, that's not a big change. Oh, no, but what I mean is that we build by default with the developer, we put as a rule that one breeding scheme, that two different breeding schemes cannot attend the same market segment, because from our perspective, that didn't make any sense. That would be like replicated efforts. But in this case, it makes sense because it's an introgression pipeline that can cut across and still not necessarily make the product. So this is just like a rule that is built in currently in the software to don't allow breeding schemes to overlap in market segments. But we can, I guess, give the freedom to remove that rule and just trust that people will not create that overlap. Independent thing. Yeah, that's. So you mean something between these two? Yep. Maybe what we can do is that in the breeding schemes part, we put an additional feature here that says if this is an introgression pipeline, and for the introgression pipeline, we gave those, we allow them to basically cut across. Yes. Yeah, I see your point. And maybe, that was a lack of clarity when we were developing it. We thought that it was kind of too much, like I said, but correct me, maybe I'm wrong, Rosa, don't take it in the wrong way. We really thought if you have a breeding scheme that is serving that market segment, and that is covering population improvement and product development, etc., why do you need another program for the same market segment? In that moment, we felt that it needed to be one-to-one, but it could be that, we remove that rule. I think that's kind of the learning that. No, that's fine how you have it. I guess that the thing is that in the same pipeline, you may have multiple schemes, right? I'm just thinking, for example, some of the people that is trying, the current scheme versus some more piloting scheme, right? Maybe this is the base SSD, and maybe I'm trying a GS breeding scheme, and they are attending kind of the same targets. What I'm trying to say is that I don't think we thought in that moment, in that particular case, where basically the same breeding scheme is attending the same targets. We always thought that if there was many breeding schemes attending the same target, there was something wrong. But I agree. I don't think that is the proper thinking. So, like I said, this is the type of feedback that we need. So let me actually take it home and ask the developer to remove that rule where two breeding schemes can attend the same market segment. That makes sense. And that also solves, I think, the issue of the introgression part. Sorry, Elisa. Please go ahead with your question if you still remember it. Can someone give a microphone to Elisa because I cannot hear her?
So in the part in the breathing pipeline, you map the region, a continent. The continent is the places where we prepare or perform the breathing, or is the target region?
Yeah, that's the same question that Shafei did. I think there's nothing wrong with putting, I would say maybe the region where the headquarters maybe is located. Maybe you can put, like, we are in Latin America. That doesn't really affect the fact that maybe your market segments are in other regions, right? Like this Mickey Mouse example, I put in like, here we're located in North America, but we are attending East Africa. So our targets is kind of different to where we are located.
I have a problem with that.
Yep.
I did it different, and now I want to edit, and I can't.
You can't? You should be able to edit. Do you think there is something with the... Yeah, no, you shouldn't. You shouldn't. In essence, everything should be able to be edited. Can you check it with a different... Are you using Google Chrome or Chrome? Yeah, that's what I was thinking, because I'm also using Chrome. But you see that I can actually edit edit Europe. Is someone can you maybe just reload? Just click on the bar and type enter again, and see if that changed actually got updated. Because no, in essence, nothing should be fixed. I mean, here nothing is fixed. Everything should be able to be edited, because we know that in general, everything will change with time. Nothing should be fixed. All right. Going back to the old. But you can't. Okay, then let me just... What about for the rest? Like for a market segment, can you edit it and change it, or it doesn't? Oh, you mean that here is not only East Africa, but East and Central Africa? Yeah, I guess we have two options here, and I guess you're the ones, I mean, you're the stakeholders, you decide. One is like I said, that you really think carefully that is not, sorry, let me just first, let's say that we're in this situation, Bert, that is not East Africa, it's East and Central Africa. And I guess the two options is just to accept that those are really, even though there's actually not Central, good catch. Maybe you just accept that those are not really the same market segment, that, if you're saying East and Central Africa, maybe you want to see it as the same market segment, but maybe they are not. I mean, maybe there's too much. So I guess you created as two different market segments, and I also want some feedback from Agnes here. Or we just put the option that you can, just drag and put as many regions as you want. I guess that's kind of the direction where you're going. That. Yeah. So, Mark, what do you think? Sub-region. Yeah. Yes, we can do that, Agnes. I guess the question is even thinking on the regions and sub-regions. Let's say that sub-region 1 is Central Africa, and the sub-region 2 is East Africa. Can we combine those two and still say that this is one market segment? Or is so broad that you have to accept, no, these are two market segments? Mm-hmm. In South Africa, okay. Mm-hmm. Yes. But basically, if we attend South and Central Africa, those are really two market segments, right? Which there's nothing wrong, right? And there's nothing wrong with defining many market segments and just saying, okay, this pipeline attends 2 or 3. I guess I just wanted to understand what is better if we just allow in sub-region, for example, to say, oh, the sub-region is East and South, or no, you have to keep, sub-region is East and sub-region 2 is South, and these are two different market segments, which is fine. You just attend it with the same breeding pipeline. In the case of currently in the software, we are not building that issue, right? Yes, but in general, yeah, the software has the flexibility to say yes, this product profile still attends multiple market segments. I mean, you can still select several, but for example, but in reality, I guess that's your point. In reality, can a product profile attend two market segments? I guess conception. Yeah. And I guess the complexity comes from the fact that the CG is not like in the companies, right? That it's very targeted. Here is like we need to kind of try to go broader and cover a bit more, even if we don't want to. So I would let that discussion to be happen with the MIPI people, to occur with the MIPI group, and but yeah, that's a good catch. Yeah. On the meantime, I will just make the change from region. Yep, good. Mm-hmm. Yeah, well, in terms of software, I mean, we can do it. I guess this goes back to this comment from Bert. Does it make sense in the, in the actual thinking of how this works in practice? I guess, yeah, the product profile can serve several countries, and I guess the market segment can also serve, I guess, all the region of countries that we're defining. So yeah, we can add, I guess, that ability for countries. That's, I guess, from the software perspective, that's yes. That's not a problem. Oh, sorry. On the market segments, but in which The last green column. Okay. Uh-huh, uh-huh. Great. Yeah, thanks, Elisa. That's good. Good catch. Yeah. Someone else wants to contribute? Yeah, in the case of the product profiles, we have been trying to just stick to the convention. What's that?
How can I edit the product profile?
You can also not edit it, the one that you have?
I mean, I can see now the product profile, but if I want to edit, I don't know.
Ah, okay, so then that's a different thing. So when you are here in the main menu, and we have the product profile part, here there is an action to actually open the product profile traits. So this is the product profile that you defined, and if you want to open it again, you have to click here on Open Product Profile Traits, and it should take you to the table. Currently, I have not defined the traits, right? I would say yield, trait type, output, meter scale, kilograms. Yes, and I guess that's the discussion that we're having with Peter and Agnes, right? Currently, we don't have a place to store all that, right? Currently, everything is in Excels.
But this should look like that Excel.
Yes, but exactly, that should look like this Excel. So I guess the current discussions with Peter and Agnes is, where do we store all that data? Do we put it here in the breeding pipeline manager and we just build over, bring the developer to make sure that this has all the functionalities that the MIPI team will need? Or they will need to create another tool specifically for market segments and product profiles, and from the breeding pipeline manager, we only keep the breeding scheme part. Because this particular tool came up from the discussions with you as breeders to get breeding schemes. There was no tools to get breeding schemes, and this is what we were discussing today. We needed to design breeding schemes. So for us, the important part came here, right? The breeding schemes. Be able to define the crossing, evaluation, and selection decisions. To click here and be able to see some crossing, evaluation, and selection decisions and fill some information and have some discussions with you. You told which traits, how many locations, are you using GS, are you using all those different crossing, evaluation, and selection decisions. But we noticed as we were working with you that there was no enough clarity. Just if we had the breeding scheme, we needed to link it to the target, right? We needed to know to which market segment, to which product profile this breeding scheme was linked to. So that's why the functionality for market segments and product profiles is here. And we have been trying to follow the lead in all the presentations from Peter and Agnes to make sure that this is built here. But it's going to be MIPI's decision at the end to say whether they want to just create something from scratch or just take advantage of the fact that there's already something halfway. But yeah, does it make sense, Rosa? Yep. And that's why I said, we cannot really at this point tell you what to do. We are really just here for giving you recommendations. But the reason why I'm presenting you the breeding pipeline manager is not to tell you that you have to use it. It's to tell you that you have to use a sketching, a blueprint software, something to document your breeding schemes. If you decide to, at the end of the day, just buy a sheet of paper and writing it there, put a plastic in and just make a hole in the wall and put it there and make sure that everyone knows that there is the breathing scheme, that's totally okay from our side. We can only give you recommendations, and we said, okay, is documented? Yes. Is in a safe place? Yes. Okay. That's it. That's what we were asking for. But you can come up with something fancy if you want. Elisa. Uh-huh. Yes, that's something that needs to be changed. Yeah. No, yeah, this one, exactly. Like I said, when this one was built, was kind of the early phases when there was these discussions. But it's just like before this was called N4Eds, now it's called breathing resources. I mean, something like that happened to us, right? That we were trying to follow the vocabulary in that moment. The software developer kept working, they kept working. And then suddenly now there is a new vocabulary that we didn't catch. So we have to address that one. Yep, that's a good catch. Yes, it has to be aligned with that template. Yep. Yeah, ideally you have those product profiles and you bring them here. So you said, okay, yeah, this should be different type of traits. We also have to put if the trait type is improve or is a threshold, et cetera, et cetera. But that's kind of the proposal that I've been telling, Agnes and Peter, that we would like them to, just tell the developer what needs to be here, and the developer will do it. That's not a problem. So yeah, you will see that probably most of the differences that you will find is on the market segment, product profile, because we need to align the vocabulary. Yep. 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 Yeah. I agree. Actually, these names came from some of the other platforms and projects. Do you remember this one on gender, etc.? They were also classifying traits. And this is actually the classification that they were using, the output, survival, quality. I mean, they didn't come up with this. I don't have time to come up with vocabulary. I just take the ones from the latest, platform. And that's the part where we need some alignment, indeed. So maybe, this is something for MIPI. And I think the fact that now MIPI is going to be like the single body on all this part of market segment, that will give us the advantage that whatever they decide, we put it here, and now there's no other way to move. Yep. Yep. Yeah. Yes, exactly. No. Yeah, I don't think we have any disagreement there. I think we also the need to create something like this, a database for market segment, product profiles, breeding schemes that is currently not covered in the databases. I mean, the databases currently have all the rest of the information, right? The trials, the plots, the measurements. Actually, when we developed this is one module of the EBS database, right? I mean, this breeding pipeline manager was designed with the specifications to just be one more module of EBS. But it can also, be adapted to be one module of BMS or one module of breed base, Musa base, etc. Yes. No, I agree. No, the ontology is something basic that we just have to just align, right? Yeah, the question is whether if currently the databases align with the new language that the new 1CG is bringing, or we should be backwards, like, make sure that the 1CG aligns with the current accepted, which I think that should be probably the way to go. Just rescue, as you said, the crop ontology that currently is accepted and just stick to that one. And the things that don't exist, okay, we bring them in. But if they already exist, well, we stick to those ones. Yep. Good comments, good feedback. We only have 7 more minutes. So if someone wants to comment something, say something. Like I said, ideally, as we're going to go in through the presentations of the simulations and the results, I would like you to always keep in mind that it would be nice if you just capture your breeding scheme. Just like we have here the market segments and product profiles, we also had that table for breeding schemes, because at the end of the day, this is your blueprint, right? Actually, even just to make sure that was kind of the idea of a blueprint, we actually create a functionality to pass it into a blueprint and create a graphical description. I mean, currently this one doesn't have really anything, right? But maybe, I don't know if there is any breeding scheme already that someone has captured. Elizabeth Parks, seems like most of them don't have breeding schemes. It says 0, 0, so basically people just exploring. Jolene, Tiago, let's say breeding schemes from Tiago. Please don't copy sensitive information from Tiago's pipeline. But let's say this is, oh no, actually there's nothing yet. There's nothing there yet. So I guess he's just starting. Trying to look for an example of a breeding scheme. So this is one from the IITA people that I tried to use as a Mickey Mouse example. Small breeding scheme, a couple of the stages, the crossing block, the different stages that they have, different decisions, different numbers. And like I said, this can also be translated into a flow chart. But like I said, if you have this information, it's kind of easier to just go back and try to look at it and see what can we improve. What are the decisions that you just look at and you feel like, is there something that can be done here? Did I miss something? Even this one is not complete. But this had many traits. Again, we can align with the new vocabulary. But you can start just thinking, okay, if here you only have visual selection, and maybe on the other trait you were using I don't know, an index, or maybe for this trait you were using blobs or blues. I mean, just try to look at it with critical eyes and see what can be improved. That's kind of the purpose of the tool, is just to make you think twice if there is something that can be done better. Anyways, I'm going to stop here because I know that it's been a long day. It's only the first day. Mondays are always difficult. Tomorrow we start with the technical stuff. So we start with the QG introduction, some theory. We'll try to make it very easy to follow. And then we start with the simulations, the questions. So I think you will have more fun. But I think this at least sets the foundation to remember that this fits into targets, into designing a breeding scheme, and it's not just about seeing simulations and thinking about technical stuff. So we see you for dinner, 6:30? 6:30 in the barbecue area, which is at the very end by the pool. Well, maybe I let you give those instructions. Is that it? Is there something else that they need to know? Just be there at 6:30. bring your bathing suit so you can actually, swim a little bit. Yep, yep. What else, Brenda? There's something else? Yeah, Chafé. Yeah, yeah, please. I'm going to stay here in case there's more questions. Yep. Mm-hmm, mm-hmm. Yes, we're not planning to replicate that part because, like I said, this is supposed to be not independent. This module is part of a database. So if that ontology is already defined in the database, this should only reflect, of course, the vocabulary, but we will not, again, put a definition of this trait is measured this way or implies this and this. In essence, it should be following the ontology of the database where this is hosted. Yeah. Okay, yeah. Well, that can be for sure added. Yeah, that's a good point. Yep. Yes, so that's exactly what I was referring when we started the discussion. So for the sake of this discussion, just with us in the reading scheme, I'm going to change this to be called stage of phenotypic evaluation, because we don't want you to get confused with the stage gate. Because here we need to put many stages, right? Because you have the crossing block, the F1 generation, or in the case of some of the clonally propagated crops, all these multiplication phases, then the yield evaluation, well, the rest of the evaluations, et cetera. So we're going to have probably more rows than stages that exist in the stage gate. So that's why here we're going to change it to stage of phenotypic evaluation or stage of evaluation, maybe not necessarily phenotypic, because it doesn't have to be phenotypic. But you can see that actually in the current fields that we have, actually we even have some of the different names that you use. For example, in the case of the foragers, we know that they like to use this 1.1, 1.2, 1.3. So our approach was to basically just take everything that we heard from you, put them there. These are all the possible stages. Yeah, so, but this just was trying to reflect actually the names of your phenotypic stage of evaluation, right? Yeah. Some of you call them PYT, some call it the stage 1. Valeria was calling it stage 1.1, and they say, oh, Eduardo, you have to, I'm not the one deciding how to name what. I mean, I cannot take that responsibility. You decide which one you use. The options are there. Dorcas.
Yeah, maybe we can, after clarifying stage of evaluation, we can add another column.
The stage gate.
Because these ones you can just assign.
Yep.
But then you can leave.
It's not only evaluation, right? It's a form of advancement as well. Without evaluation.
Yeah, that's the point, Bojan. That's why I didn't put anything here, right? I mean, currently you can see that, yeah, because, for example, crossing block is not a phenotypic evaluation. The only thing that we need to figure out is how to differentiate that this is not the stage gate. That is not the stage gate process. Maybe I just need to put in the actual definition that this is not the stage gate or something like that. Yeah. Yeah? Yeah, no, for sure, you need to map it. No, but let's not actually, that's exactly what I don't want, that you start to get confused, by the stage name with the things that you have to do. I mean, in essence, this entire table, what it's trying to help you is to identify the activities that you do in a given season, right? That's the whole point. In a timely manner, trying to put, okay, if I am in year 1, and I am in season 1, I am in year maybe 1, maybe you have 3 seasons. Let's say that you are very aggressive. What do you do in those 3 seasons, right? I mean, of course, you put as many rows as years that it takes you to complete a breeding cycle. But in essence, then you start to say, okay, in season 1, year 1, I'm planting these many individuals. I'm putting these many plots, this experimental design. And that's why if you ignore the stage name for a minute, which is what is causing confusion, it might be that, in the first season you have the parents, you're just planting them. Maybe in the second season you have the F1s growing. Maybe in the next season you have the F2s. And maybe in the next season you have the F3s. Or maybe you did DHs or whatever, but maybe this is already year 2, season 1. And you have to start putting, the information. Not all the table has to be filled. Don't think that all the decisions you have to put something. For example, in the crossing block, when you have the parents, that you put them in the greenhouse, basically maybe there's no experimental design. Maybe total number of locations, maybe it's just 1. Maybe you don't have to worry about plot width. I mean, maybe you can ignore many of these crossing evaluation and selection decisions. For example, the phenotyping, I mean, you can put all the traits, but maybe there is no phenotyping in the first stage. Maybe it's only when you get to, I don't know, maybe in the F3s, you're already looking at this trait that I'm going to call it, maybe I'm going to call it yield. And maybe for that particular trait, maybe you, at F3, you really do something. Maybe you are just getting some blobs there from 2 locations. And maybe in trait 2, maybe that is just disease resistance. Maybe you're only taking a look at those 2 traits in this stage. And again, maybe take a look at some blobs, but maybe this is only 1 location. But you can see that for the rest, or the previous generations, there was no phenotyping, so you don't have to put anything. So what I'm trying to say is that you don't feel like overwhelmed for all this information. You just put the information that is relevant for the strategy. Yep. Exactly. Yeah, but you see, this is somehow a multiplication stage. Let's say that the F2, you don't do anything other than just increasing material, right? And you still put it there just to make sure that you are capturing that this is happening, and it's happening in season 3 of year 1 in this case. So the idea is that you actually put as many rows as stages. Sorry, as many rows as the different things or activities that you do for completing a breeding cycle. So before we finish, let me just throw that idea. The breeding scheme should cover all the activities that it takes you from planting the parents. This row basically represents the timeline. When you put them in the greenhouse, they start to grow. Then maybe you make the cross, you harvest the seeds, and all that row. You get the seed, now you go to the F1 seed, you plant it, it grows, it gets maybe selfed, you harvest the seed. Next row, you plant the F2 seed, you let it self, and so on. Of course, depending on the type of crop, you might not use the same generations. Maybe everything is F1 for the clonally propagated crops. You are, let's say, in year 1, year 2, season 1, season 2, season 3, but the generation doesn't change. It's the exact same material. It's just getting propagated. And that gets reflected when you get to the multiplication or crossing decisions. Because in the case of some crops, maybe what they are doing is to actually, crossing or multiplication methods. So maybe they are selfing, F2, F3, But in the case of a clonally propagated crop is just cloning. Uh-huh. Like some comments. Yeah, for sure. That's. Yeah, no, that's a good point. We can put it at the end just for kind of summarizing. Yep. Yeah, I mean, we know that anyways, there's always going to be some variation, but this should reflect, on average, your strategy, right? So it might be that, you are cloning. If you are cloning where you're not doing any cross, you might have to leave this in blank. But if you are, a crop that, let's say, is making you are in this stage and maybe you're making the test crosses. Like you said, there is stages where you don't do necessarily selection. Maybe the stage is just for seed multiplication. Let's think on sorghum. They're making a test cross in this stage. So here, in crossing, is going to be test cross. So there was an option for test cross. And then you have to specify, okay, maybe I'm going to make this type of cross, depending on, is that dioecious or monoecious. Maybe you say, okay, I have this many. And you can see that we even put like males and females. So you can say, okay, I'm going to take 2 testers like males against 100 females to specify that, okay, during this season, I did a test cross, and I crossed these many testers by these many females. So, for example, this is test cross, and let's say that you have a specific, you can leave it in blank, but there might be that you make some random crosses, or maybe something based on GPCP, optimal contribution, based on pedigree, based on complementation. I mean, there's different options when you make a cross, right? Like I said, it's just a general strategy. But this season might be, okay, this is a test cross, and what I'm doing is that I have, I don't know, potentially, number of potential male parents, maybe it's 2 male parents by 100 female parents. All of them are diploid, and just look, we had to even put ploidy, because in some crops, you don't cross within the same ploidy. I mean, in case of banana, they cross, the males are diploids and the females are triploids. And it becomes complex, but we needed something general to reflect everything. You might think, who cares the ploidy? Okay, you don't have to use it if it's not a thing for you, but for some crops, it might be a thing. Mm-hmm. And like I said, it's a lot of information. We know it, and I know that that's why some people just hate when we get to this exercise. I can see Bert is smiling from the very beginning when I said it. But like I said, it's good to formalize it, to document it. You don't have to change it every year, right? It's just, actually, this is your recipe that we said about the factory, right? This is your recipe, and you actually just change it if you have a good reason for it. If you already, made some experiments and made some simulations and confirmed that you should stop doing RCBD, okay, now we start doing a different experimental design, we document it, we make a change. But we expect that this is a one-time exercise that is annoying, it takes a lot of time, but it's not done every season, right? It's not done like every time that you wake up. Does it sound good, Melissa? Nice. Questions, comments? Go for it. Yep. Yeah, that's a good one. So in some crops, they really like to specify that this might be an F5, F3 derived, right? Or an F6. Yeah, but they want to still specify that it was derived at the F3 level, right? Again, for some crops, this is not a thing. For some others, they really want to see that there is the ability to say from which generation we started to develop the lines. That we started to say, at this generation, we started to make the inbreeding. Yeah, I think from the parents, there's not really a problem, because you could say it. I mean, if this is a lane program and the program is starting with parental lines, and you want to specify that these are F8, well, okay, that's a good point. I mean, you could just say, okay, the lines that I'm using, they are derived from an F8 generation. I mean, I really make sure that they were not, that they were really inbred before I take them to the greenhouse. But again, don't get confused in this part on the parents, because we noticed that many people that were using it, when they got to the phenotypic evaluation, they started to specify that these parents were phenotyped for many, many traits. But that's not the case. Again, what we're trying to reflect is that you actually are putting those lines in the greenhouse and they are growing. When they are in the greenhouse, you are not evaluating them. So every line is trying to reflect the timeline of the life of these plants that are growing. That phenotyping that you're referring to, it will come later. It will come at the later generations. At some point, it will show up. When you get to the stage 1, stage 2, stage 3, they will show up, and they will show up for the traits, how many locations, how many blues, blobs, G blobs, was it an index, was it a, et cetera, et cetera. Yeah, please, Elise. Yep. Exactly. Well, the ones that you want to put in the evaluation, right? Yeah, it can be everything in the product profile, preferably. For example, if you click here in the plus button, you can see that currently there is only yield in output traits. But if you just click here, basically it creates an additional trait for you to have more output traits. So you can put. Well, that's actually a good suggestion. Well, it's not a bad suggestion. Yeah. No, that's actually a terrific suggestion.
My first stage, I used the crossing block, and then generation, I put parental, derived from open pollination.
Yeah, in your case, yeah, that's forages, right? Yes.
And then I started F1.
Yeah, F1. Yeah, looks good to me.
I have a stage where I recombine the sexual lines to cross again. But I don't know how to reflect it there.
Well, probably it should be in the crossing decisions, right? In the strategy. So what you're saying is that in one generation, well, first, for example, you can select what is being recombined, because, and this is also a complex part that I haven't gone through, but we can have different levels. This is trying to reflect what I call the population structure in a breeding program. You always have a structure in your breeding program, right? Because you have families. Some of them might be half sieves, some of them might be full sieves, some of them, just are sublines, etc. So if we were to reflect the population structure, it could be very complex, actually. It can get very, very complex. Especially for the pedigree type of schemes, where you derive sublines, and you derive sublines out of those sublines, basically the structure can become quite messy. But on average, most of the programs that we work with, we found out that they could be captured with 4 layers of a structure. So possibly half sieve families, F1 or crosses or full sieve families, number of individuals, let's say that within the full sieve family, and potentially the sublines, if there is some pedigree scheme, but not too strong. For example, most of the programs only use these 2, because most of them, let's say, they start with, let's say, parental individuals, inbred or non-inbred. Let's start, I don't know, maybe with 30 parents. They put them in the greenhouse. Then they start to define, how they were growing, how they were, put in the greenhouse or in the field, with which size. I'm not going to go through that. Just for a minute, I'm going to say they start with 30 individuals that, are the parentals, the founders of this breeding program. Like I said, for a breeding cycle. Like, let's say this is the starting breeding program. Then, normally, when you get to the crossing evaluation, to the crossing part at the end, you get how to cross those 30 parents, right? Because you said, okay, we had those 30 parents, so maybe 29. Let's say that actually when you put them in the greenhouse, you notice that one was actually not the right parent. So you started with 30. You ended up with 29 at the time of doing the crosses in the greenhouse. Sorry, let's assume that actually this is just as both. So potentially you could do 435, let's say, possible crosses. I said 29 actually. And then you decide, okay, the total number of crosses that I'm going to do for those potentially 400 is just 90. And if I'm using lines, doesn't matter how much progeny you put because they are just F1s. So they are totally identical. But if this was a clonally propagated crop, an outbred crop, maybe you can put like how much progeny you're going to get from that cross. And ideally, these numbers that you're putting at the end are the initial numbers for the next line, right? Because now you have 90 crosses, F1 or full sieve family crosses. And then, how many did I put there? 60? No, 100, 90. And this is the new structure. So when you have the next generation that you're growing, it's a nursery with about 9,000 individuals that have this population structure. There is 90 full sieve families with 100 individuals each. But at some point, the breeding programs really don't care about the structure. When you get to the stages of evaluation, like PYT, AYT, what I have noticed is that even if you have some population structure, you don't care. You just start to say, oh, I have 1,000 lines. Maybe I'm thinking like in the wheat program. Sometimes you have these lines, but when you are in the late stages, maybe you're still considering the population structure, Boya, I don't know, but some seem that they don't care anymore. So even though this 1,000 might belong to some population structure, we are not capturing it anymore. Yes, so Cecile, yeah, I see that you. Yeah, we know yours. Yes, I think you have two breeding schemes that should not be combined in one single here sheet. Exactly. Yeah, which is the thing that we need to address, yeah. Yeah. Completely agree. Yeah. Completely agree. I think that take it as actually my mistake. There should be this rule to allow to actually say that more than one breeding scheme can attend a given market segment. So yeah, I hope that I put that one. If not, yeah, that was the first thing that I captured. No, yeah, good catch, Cecile. Like I said, I agree, but I think that in your particular case, those are two breeding schemes. Actually trying to combine those two things here, it would be really, really painful. Well, I'm sure that you already went to that pain. So sorry if you already tried to do it in one. No, I think those are two breeding schemes. Yep. Rosa, I see like you're still thinking like, Yeah, it might be that you have two different schemes. Yeah, I mean, if you feel that that cannot be combined, yeah, it's like I'm going to give you a clear example. I mean, in the case also of maize, Joseph at some point, he also have the SSD scheme and the double haploid scheme. You can try to put everything in one and just say that it's happening in parallel, right? Same year, same season, 2 rows, but it just gets confusing. Instead, just have 2 schemes, which anyways makes sense. It's the DH scheme, SSD scheme, both are serving the same target. I think that makes more sense. So yes, maybe we need to look specifically at your details to see if it makes sense to better just put it in one or separate it. Bert. Yes, currently it's automatic, and actually it's not. Yes, it's still the same name. Yeah, actually, someone else in the past training they made that point. You actually already passed it, but I'm going to write it again just in case Solomon is not working on it. Yes, currently they take the same name. Yep. Yeah, and actually I don't have the solution yet for that one, Bert. We need to check with Agnes and Peter, because I know that they also came up with some convention on how to name them or make acronyms. Yeah, just to follow our tradition of acronyms, let's make more acronyms.
Please leave that column with the comments.
But we need to come up with some sort of acronym or just code to say this market segment has this code, but always that can be always differentiated. Yes, but what Bert is saying is that currently, because it's only taking, we didn't want to take all the columns to create one identifier because it was going to be like a huge identifier. So we said, no, just pick this, and this, which are the more relevant. Well, it turned out, as Bert found already, that if you have two that are very similar and they only differ by one that is not considered for the code, they are the same. So we need a unique identifier that we need some help from MIPI and Module 1 to get to it. Yes. 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 Yeah, but maybe you didn't find, currently there's two market segments that have the same, but it may happen. That's the problem, that if we do not consider all the variables, it can happen. And that's basically what some discovered. Yeah. Well, the thing is that you actually have to comment with the ones that you already defined with Peter and put them here. Like I said, this is not a tool to define them. It's to upload what you already defined with Module 1. I guess the only thing that we have to figure out, because I thought I was following, the convention that Peter gave me at some point. Like I said, several months ago, he gave me this convention. Oh, I'm taking this and this and this and this. I combine them, and I come with one acronym for the market segments. And I say, okay, perfect. We put that, and that's kind of how we created supposedly these codes. But then, as the people started using them, they figured out that, okay, look, if I just change from this to this, I only change the end use, and I said, okay, this is frozen. Oh, wait, okay, this is one that is being considered. So that was not the issue. But there's always at least one, because there's so many that we said we cannot put them all. It has to be key features, the ones that define the naming or the code. But exceptions always happen. Agnes. Like TFS1. Oh, okay. Yes. Yes. Yeah, that's what we need to double check again, the current thinking. Thanks. Good point. But this was good feedback, eh? Like I said. I think, besides the burden, there's some benefit on having the breeding schemes defined, especially to, communication with other people like the QGs and the biometricians, or sometimes people that is not really related to breeding. It might also be painful for them to understand at first, but after that, they can just read and say, okay. It's like a map, right? I mean, also with the planes of the architect, it's not like you understand them quickly, but once they show you, okay, look, this is how you read them, then you can just take it and understand it, even if you are not part of that field and you are not the expert. So yeah, let's close here. It's 5:30, and I want you to have an hour before you go for dinner. Don't fall asleep for more than an hour. Otherwise, you will miss the dinner. But that was good. Let's go and take a rest.